Good evening, good morning, good morning, good morning, good morning, friends. Good morning, cute girl. Good morning, Arsh, Arsan. So, good morning, people. I hope I'm clearly visible and audible. I cannot see, yeah. So, I guess now I am live. I can see the screen as well. So, good morning. Tell me, how are you? You had an awesome session yesterday night also. I was watching Ambika ma'am, and the session was really very useful for the students because yes, they were a large chunk of serious students who had joined yesterday, and yes, with that intention, with that feeling, with that motive of landing to a government medical college because the D-Day is just very near. It is 3rd of May. So let us wait for a few minutes, maybe 1 or 2 minutes till the time we can obviously chat. So Bhavna, yes, Bhavna. Good morning. Yes, beta. I have been watching your although I am new to this NEET platform, although I am quite old to the version of teaching. I've been teaching since 2012, but yes, the platform is relatively new to me. So maybe few of the students, I mean, most of the students do not know me because yes, I have been seen more for the JE aspirants. But yes, my dear friends, now the level of NEET which NTA is trying to meet is quite competent as per JE mains. So do not worry. Yes, we have finished physical chemistry yesterday. I mean, half of the physical chemistry, the I would rather say that was the most relevant physical chemistry that we have done on the yesterday session. You know why? Because mole concept, redox, the basics of atomic structure will help you to build an edge for inorganic chemistry. uh, Mole and redox will help you to deal with quantitative questions of organic, also the POC, and of inorganic chemistry also. So yes, they were. Sir, your voice is dangerous. Okay, so I hope that dangerous is a positive thing. Arsh, thank you very much. Although I have received that statement quite a lot. So, yes, thank you, beta. God bestow some of the blessings to everybody, and we just have to explore that what God has bestowed upon us, and we have to continue on that path. Chalo beta. So K Narayana, sir, what is the job today? Obviously, the job is to complete the complete physical chemistry, and what are we left with first today? So topics that we will be dealing today will be, obviously, the first will be thermodynamics. Thermodynamics, we will be first finishing this. Post this, we will be dealing with the thermochemistry side of, because yes, NTA generally, I mean, previously this was famous for them, but yes, now NTA has found interest in dynamics as well. Then next is we'll be dealing with chemical equilibrium. Then we'll be dealing with ionic equilibrium. Don't be scared, but yes, ionic equilibrium, I mean, very important topics only, and those important topics will be more than sufficient to make your questions correct for your NEET examination. Don't worry. And then we'll be directly switching to 12th organic, where first solution and colligative properties we have already done, and after that we have to do chemical kinetics. But yes, chemical kinetics I will only do the theory part. Why theory part, sir? Because theory is nothing but numericals only, because they just have four type of questions over here. First type of question is on zero order reaction, then on first order reaction, then on identification of order and molecularity of a reaction, and the fourth is the collision theory. So even the January attempt, all the paper of the January and April attempt, I am talking of 20 questions by 20 paper by NTA. They have just focused on these four areas in chemical kinetics. So it will be just a piece of cake for us, है ना? So, but yes, you obviously have to practice more and more, and I am here for your practice. And last we'll be finishing with electrochemistry. So this will be our job. The first, I guess, till equilibrium we will be doing in the first half, and this will be covering in the second half. What is first half and second half, sir? I guess this will take around maybe 2 hours, and then we will take a break, and then we will I mean, not a strong, I mean, we just a 10 to 15 minutes break. That's just a break to have two rotis, two chapatis very quickly, and then we'll be meeting. So around 1 p.m. we'll be taking a break, and I guess we will be finishing around 3. So the job, the planner is clear to everybody. So put and hit the comment screen duration beta, then 2 hours, so around 3 will be finishing, so it will be somewhere around 4 hours. So hit if you are done, if you are through with the planning, hit the comment screen with okay, start, so that we may also have that inspiration. And let's say the poll will be working today at my end, then we can clearly start also. Chalo. Equilibrium, I don't know, sir. Should I leave it? Beta, Bhavna Patil, don't worry. I will be dealing with the relevant concepts of equilibrium. I mean, I will not be juggling with the whole theory. And whatever relevant, beta, if NT is asking a very easy question from equilibrium, then what? Then you will feel, you will regret leaving this. So therefore, do not have a habit of leaving any topic, because you do not know if whether you are landing with the easy topic from the chapter, with the easy question from the chapter, then it would be a crime not to attempt it, na? Because that one question can take you from a private college to a government college, because one question, I mean, one question, attempting question wrongly also makes a huge difference in your AIR. So chalo, what will be the next exam next time, sir? I will take the next exam next time, sir. Okay. Good morning, sir. It is enough. It is more than enough. Good morning, Padmana. Chalo. Sorry, NEET. Okay, chalo. This is the first question, and obviously it's a integer type question, so I am giving you 60 seconds to attempt it, because I just want to see whether my poll is working today or not, because yesterday it was not. So start attempting, guys. Sir, I am will following. That will you be telling, sir? Perfect, Bhavna. Perfect Bhavna. Chalo. So I need answer. This is just a theoretical start to thermodynamics, where the question is telling you you have system and you have surrounding. The system and surrounding are separated by a boundary containing a wall. So the boundary containing that wall has some features. So these are the features of those boundary. So I have given you this is just a theoretical question, and I have given you options also. So can you give me the answer? I mean, this is just a matter of you reading the question properly. So reading words per minute also matters for your NEET examination, guys, and it can only be increased once you have commitment with your concept. So obviously, if you just see, the first wall is a rigid wall. So rigid wall is definitely a thing which cannot be moved, is rigid. So A goes with 4. If you just do A goes with 4, then try to eliminate the options. Then I guess there is only one option having A4, but because we are learning, so obviously answer is A, but because we are learning, so I'm telling you everything. Next thing says isolated system. Now, what is an isolated system, sir? Isolated system means there is no exchange of heat also and matter also with the surrounding. So no exchange of energy and matter, as in B is 3. What is a open system, sir? Open system can exchange anything. It can exchange heat also, it can exchange matter also with the surrounding. Now, what is a non-rigid system? Obviously rigid means which cannot move, so non-rigid means which can obviously easily move. What is a closed system? So closed system is like a cup which is closed, which is packed. So matter can't be exchanged, but obviously it can be heated or cooled. So energy can be exchanged. So no exchange of exchange of energy only, and obviously matter will not exchange. So I hope my poll is working, and let me see. Yes, now today my poll is working, and everybody has given the right answer. Bhavna being the topper. Okay, moving to today my poll is working, so we'll be having this advantage of poll as well. Moving to the next question. Just read the question, and your time starts now. Read the question, and your time starts now. I've I will be helping all the students with the concept also, but yes, for the students who are here to practice, obviously they can attempt, and remaining of the students can read the question and can listen to me properly. Now, the question says quantity of work in joules done by the gas if it expands against a constant external pressure. Now, beta, if external pressure is constant, if external pressure is constant, that means the process is irreversible. I hope everybody is with me on this. And what is the formula of work for an irreversible process? For an irreversible process, work irreversible is nothing but negative of external pressure times of delta V. So what is the external pressure? Sir, external pressure is given out to be 0.98 atm. Unit is atm into change in volume. The change in volume is also given. It is 25 liters. So the unit will be atm liter, but you have to give the work in joule. So rather you should know the conversion. So what is the conversion? Sir, we definitely know 1 atm liter is exactly equal to 101.3 joule, and it is approximately equal to 100 joule. I mean, if you do not put the, because you are definitely going to have options, so you can approximate also, it is 100 joule. So this will rather be, I mean, this is 100 and this is somewhere around 25 only, because this is 1, so 1 into 25 is 25, approximately 25 into 100. So this is somewhere around minus 2500 joule. I hope everybody is clear, somewhere around. Now, because we have options, so 2500. So who is giving us the 2500 option? This is close to 2500. So option 3. That means option 3 is your answer. Okay, I guess now my poll has again stopped working. So nevertheless, chalo beta. Moving to the next question. I hope the previous question was clear to everybody. Yeah, C. Row 1. Row 1 is answering A. Sayyed is also answering. Okay, you must be giving answer for the previous question. Perfect, guys. This is the next question. Let's try and attempt this one also. Let's see if I have the poll. Students are showing over here. Then why it is not working? Chalo, let's try again. If at all poll is coming to you, you can answer, or else you can hit me with the comment screen, because you are here to practice. This is not going to be your OMR answer sheet. That will be in your paper. So, but you can obviously attempt, but make sure that you are attempting with the time restriction in your mind, because time is the money that you are going to earn while giving your paper, so that you can manage all the physics, chemistry and biology in your NEET examination. So the next question says, 1 mole of an ideal gas at 25 degrees Celsius expands in volume from V. This is V1. This is V2. That means the gas is expanding. Okay. In the previous question, I guess the unit. Haan beta. One more thing. In the previous question, actually the work is coming out to be negative. But because none of the option were giving that negative sign, so we have just focused on the magnitude, because the theory is also telling you quantity of work done, and work done by the gas is always negative. Work done by the system as per sign convention of chemistry is always negative. Work done on the system is positive. But because none of the option is having that negative sign, so we are presuming that they are only asking about the magnitude. So that's why we are only answering the magnitude and not focusing on the sign. But yes, if at all there is an option with the sign, then that will be a more preferable option. I hope we are clear with this, because now you can see the negative sign as well. So now you will be focusing on the sign as well. Sometimes that sign is not given. That means they are only focusing on the magnitude. If at all it is given, then you have to be vigilant about the formula which we have used. Now, the mole of ideal gas at 25 degrees Celsius expands in volume from this much to this much at constant temperature. Now the temperature is constant. Sir, The what work in joule is done if the gas expands from vacuum? First thing, sir, internal energy is a function of temperature. Although it is not used over here, but I am giving you every theory also. So although internal energy is a function of temperature, therefore change in internal energy is zero when temperature is constant. This is point number one that you should always keep in your mind. NEET loves this. Now, small amount of work done, whether the process is taking place reversibly or irreversibly, it is independent of the fact that small amount of work. What is small amount of work? A differential work, a packet of work, as in dW. Beta, dW is equal to minus P external into small volume change. If at all you have isochoric process, then any work, even reversible or irreversible, will be zero, because the packet which you are going to integrate will be zero. So for an isochoric process, work will be zero. And if external pressure, what does expansion against vacuum means? It means you are providing zero pressure externally. So whenever external pressure is also zero, then also dW will be zero. Therefore, dW is also zero. Change in internal energy is also zero because temperature is constant. So obviously by float, which is first law of thermodynamics, which is change in internal energy is equal to Q plus W. So because this is also zero, this is also zero, so Q also will be zero. Although they have not asked anything of that sort, I am just giving you complete information about the first law of thermodynamics and the application of it. Chalo. So what shall be your answer? Obviously, sir, option 4. Let me see how many of the students have answered. No. Acha, you have answered incorrectly. There is no leaderboard, but I can see those students have answered. So I hope everybody is clear with this. Moving to again the next question. Answer, guys. Answer. The internal energy change. Now I have already given you the thinking process, the thinking formula regarding it. The internal energy change when a system goes from state A to state B is this much. System is going from point A, state A, to state B. I do not know how it is going, but it is saying that change in internal energy is 40 kilojoule per mole. Sir, internal energy, every thermodynamic property is a state function. It do not depend upon the path. So whether you are going like this, whether you are going like this, or whether you are going like this, it will not impact the change in internal energy because they all are state functions. I hope everybody is with me on this. Now, if the system goes from A to B by a reversible path and returns to state A by an irreversible path. Now the question is now telling me in English that system is going from state point A to point B, as in state A to state B. First it is going how? First it is going reversibly, and it is coming back how? Irreversibly. Then you have to determine for this change what will be change in internal energy. Sir, you have already told us internal energy is a state function. So if I have started from here and if I have came back to this point, obviously change will be zero. Do not have to think about anything. And this is okay. So I guess you are answering for the previous one. Let me see. No, I guess the poll is not working in that case. No worries. I'll not be using the poll. Shivansh, Pritham. I hope everybody has got the answer. Option 2. Chalo. Moving to the next one, guys. Now, attempt this one. Now, this is a theoretical question. Why? Because again, you will be framed a MCQ on the basis of this. Please say anyone this sample questions. Okay. Now, this is a theoretical question, and the reason I have taken this question, I mean, the reason we have been taking such questions in between of our slides, because the complete theory can be taught using the relevant questions. So here, let us attempt the question and try to be comfortable with the theory. In this process, in a process, this much of heat is absorbed by a system. That means Q is equal to plus 701. Why? Because the sign convention says heat given to the system and work done on the system should be positive. So this much of heat is absorbed by the system, and this much joule of work is done by the system. So work done by the system, therefore it will be negative of 394. What shall be the change in internal energy? So this is just an application of first law of thermodynamics, which says that delta U is nothing but it is equal to Q plus W. Q is 701. W is minus 394. So this is quite simple. 11 minus 4 is 7. Then 9 and 9 is 0. Then this is 6. This is 4. I just check. 700 minus 400. It should be 300, no? 700 minus approximately 400. So it should be 300. Just check. 11 minus 4 is 7. Then 9 minus 9 has become 0. Then 6 minus, yeah, it will be somewhere around 300. Okay, perfect guys, perfect. Sir, can we recall this question for NEET? हाँ beta, because these basic thermodynamics questions are definitely going to be asked to your examination. So you just have to be comfortable with application of that. Chalo, moving to the next one. Now, again, a simple application and a practice to attempt thermodynamics. चलो सर 3 दिन में बिना पढ़े नीट कैसे क्लियर करें? ऐसे एटलीस्ट अभी पढ़ें. Vinay Upadhyay. So Mr. Upadhyay ji, at least you can read right now. Moving to the next question, which says, a sample of liquid in a thermally insulated container, a calorimeter, is stirred for 2 hours. So I have a liquid in a container. Calorimeter is a device which is used to calculate the heat exchange between system and surrounding at constant volume also and constant pressure also. At constant volume, it determines internal energy change of the system. At constant pressure, it determines enthalpy change of the system, because heat exchange at constant pressure is delta H, heat exchange at constant volume is delta U. Make sure you remember this. Heat exchange at constant pressure is equal to enthalpy change of the system, and heat exchange between system and surrounding at constant volume is equal, it will give you the internal energy change of the system. I hope everybody's with me on this. Now, coming to the question says a sample of liquid in a thermally insulated container. Thermally insulated container, as in there is no exchange of heat between system and surrounding, is stirred for now for 2 hours. It is some work is done on it externally. It is stirred by a mechanical linkage to a motor. The stirring is happening with some motor. Now for this process you have to determine, sir, obviously because it is thermally insulated, that means there will be no exchange. Okay, it is thermally insulated, that means there will be no exchange of heat also, and whatever will be its temperature, that temperature will also remain constant. So because temperature will also remain constant, therefore delta U will be 0. Delta Q is obviously 0, and because we are working on the system, so work done on the system will be some positive thing. So obviously your answer will be clearly okay. Just hold for a second, guys. Here the theory is saying a sample of liquid in a thermally insulated container, a calorimeter, is stirred. Okay, so beta, the thermal insulation means obviously you are not supplying any heat, agreed. But if I am stirring it from outside, if at all I am stirring it from outside, maybe because of the mechanical stress, the temperature, I am supplying energy to it, no? So maybe the temperature can rise. How can we say it is thermally also, it is isothermal also? because the question is it is thermally insulated, as in no heat exchange. So for this we are definitely sure. But if at all I'm stirring using a motor, maybe the temperature can rise if I am using a motor of very high rpm, and the liquid solution is not capable of digesting all the heat and working. I mean, there may take some chemical reaction, or there may some take a process inside the liquid. So we cannot be sure that temperature will be constant. So what we are sure of, that q is 0. So q will be 0, q will be 0. What about work? Sir, work is definitely positive. So because work is positive, option A is also saying work is negative. So work is positive. Now you can think of delta U. Sir, because you are supplying heat, although we are working on the system, but that work can also rise the temperature also, because I am working on it. And because internal energy is a function of temperature, and because you are working on the system, so maybe the temperature of the system can rise. Therefore the change in internal energy will also be positive. I mean, I can give you another logic also, that we know delta U is equal to Q plus W. This is one way of thinking, and you can also think mathematically using float. Delta U is equal to Q plus W. For the question, what are we sure of? Sir, we are sure that Q is 0. So if Q is 0, then delta U is equal to W. Because we are working on the system, that means work is definitely positive. So obviously, if work is positive, that means delta U, which is equal to W, will also be positive. So your answer will be option 4. I hope everybody is clear with this. I mean, yes, this was a theoretically, you may take a few seconds, but that's why we are practicing over here, so that in examination you may not take that much of time. I hope we are clear. Sir, please tell high weightage. Okay. Beta, whatever physical chemistry things we are doing, we have taken around 3.5 hours of class yesterday, and we'll be doing some 3 hours or maybe 4 hours of work today. And whatever topics, whatever chapters I've taken, I have made this thing a point that I'm completely discussing the theory also regarding the questions. So this is important, beta. है ना? चलो. Moving to the next question. This one. Attempt this one, guys. Attempt this one. Attempt this one. Okay, perfect. So the question says, I hope few of you have got the answer. The question says 1 mole of an ideal gas at 300 Kelvin is expanded isothermally. Now the question is saying isothermally, that means delta T will be 0, temperature constant. So delta T 0, that means delta U will also be 0. Acha, you do not have to read the question now, because it is asking the change in internal energy. Sir, isothermal process containing an ideal gas. So if temperature is not changing, so internal energy will also not change. A highly probable question for your NEET examination. They gives you with lot of vague information so that you are indulged in it. But if you are sound enough theoretically, conceptually, then obviously you can save time also, and you can score good marks also in your examination. Moving to the next one. I hope everybody got answer to that one, guys. Chalo, next one. Can we do this? The question says, now the question says, in which process net work done is 0? In which process you have 0 work done? So, sir, isochoric, you have already said small packet of work, as in dW, is always equal to minus P external into small change in volume. So whether you are reversible or irreversible, if volume change is 0, then work will be 0. So for isochoric process, work will definitely be 0. Any type of work, reversible or irreversible. Free expansion, sir, P external 0, then also small work will be 0, so any work will also be 0. So both of them. Adiabatic has Q 0. So delta U will be equal to W. So you cannot say work will be 0. It will be dependent upon delta U. So obviously option 4 will be your right answer. Perfect. Moving to the next one, guys. Attempt this one. Attempt this one. The question says, when 1 mole of gas is heated at constant volume. So now volume is constant. Sir, volume constant, that means D change in volume will be 0. So because change in volume will be 0, so again I hope you remember work will be 0. So work can't be any magnitude. Yes, it can be 0. No, it can't be of any magnitude. No, it can't be of any magnitude. So just without application of float you can land to some questions of this sort, but because we have calculated work, because we have estimated that work will be 0, so applying float which says delta U is equal to now Q because W is 0. So temperature is raised from this to this, heat supplied to the gas is this, then what? Okay, heat supplied is this, that means Q, you are giving heat to the system which is plus 500. So Q is plus 500 joules. So delta U and Q both are equal and they will be equal to 500. You do not have to use any formula. Chalo. Moving to the next one, guys. Attempt this one. The net internal energy change in reversible cyclic process. Sir, why you are doing this again and again, beta? Because NTA is going to do this with you again and again, the same conceptual logic. Net internal energy change for a state function, if the process is coming back to the same state, then it will definitely be 0. I hope everybody is clear. Chalo. Aapke, okay, perfect. Moving to the next one. Attempt this one, guys. Now, everybody should know that if you have a PV graph, if I have a PV graph, then work done is equal to area under the PV curve. So, sir, if it is so, then we just have to see the area. Obviously, system is going from point A till point B. So, area under curve, that is this area, will be maximum for what? Sir, it will be maximum for 3. It will be relatively lesser for 2, and it will be least for 1. For 2 it will be more, for 3 it will be much more. So 3, 2, 1 as an option 2. A simple logical question. I hope everybody is with me on this. Moving to the next one. Attempt this one, guys. Now, 1 mole of an ideal gas. Okay, you can attempt this one. So your teaching is so great. Okay, Mr. Pathak, thank you. Your teaching is so great. I have learned most of the topic. Thank you very much. Thank you, Mr. Pathak. Chalo. Moving to this one. I hope you can attempt this because we have seen such questions a lot. So a final call for such type of questions, then we'll be moving to the next topic. 1 mole of an ideal gas at this much temperature is expanded isothermally. Sir, again this is isothermal, so temperature is constant. That means delta T is 0, so delta U will also be 0. From an initial volume 1 liter to final volume 10 liter. Delta E for this process. Sometimes NCRT internal energy change, which is generally we write as delta U, but NCRT loves writing it as delta E. So this is the reason I've taken this question again, because change in internal energy, sometime it is also mentioned as delta E, and definitely it will be 0. Why? Because our isothermal process. Okay, moving to the next one. Attempt this one, guys. I hope everybody is clear with this. Row 1, not 3. I hope you got that. Chalo. Shivansh Gupta. Perfect. Moving to the next question. You have to match Obviously this is also a theoretical question, but yes, it is a question to tell you, it is a question to educate you regarding the type of processes you have in a system. So I hope you have got your answer. Now let me attempt it for you. A process carried out in infinitesimally slow steps. Sir, in each step, equilibrium exists whenever our system is going from point A to point B, and it will take infinite time to complete. That means the process is taking reversibly. So A is a reversible process. So A is 3. That means, okay, if you just do A is 3, you will get option 4. But because we are learning, so a process in which no heat exchange enters or leaves the system, obviously it will be adiabatic. A process carried out at constant temperature. So if the temperature is constant, then it will be isothermal. And cyclic process has all the thermodynamic variables because they are state functions like internal energy change, enthalpy change. So change of that state function will always be 0 for a cyclic process. So 4 will be your answer. Moving to the next one. Huh. Quickly going to the thermochemistry side of thermodynamics, but yes, slowly. So answer this one, guys. Assume each reaction is carried out in an open container, then for which of the reaction you have delta H equals to delta U. So for any chemical change, is your poll working today? No beta, my poll is not working. We have tried it for the first few questions, but it was not working, so I've stopped doing it. Now, if for a reaction mixture, enthalpy change is equal to internal energy change plus, technically it is change in PV work, but for a chemical change, this change in PV curve is also equal to for a chemical change involving gases. I am saying for a chemical change involving gases. For solids and liquids, practically change in PV is 0. So for solid and liquid system, delta H is approximately equal to delta U. But for a gaseous gaseous components undergoing a chemical change, this PV can be written as nRT. But sir, moles of gaseous component will be changing. So under constant temperature, it can be written as delta H equals delta U plus delta Ng, because only moles will be changing. Universal gas constant is a universal gas constant, R is a constant, so it will be coming out of the change. And we are assuming that every reaction is happening at a constant temperature, so this T is also constant. So the formula becomes delta H is equal to delta U plus delta NgRT. So ultimately we just have to focus on the value of delta Ng. So if delta Ng is 0, then for a chemical change, delta H will be equal to delta U. So which has 0 chemical change, 0 delta Ng. So here delta Ng as in moles, summation of moles of product minus reactant. So this is 2 minus 1. So this is 1. So obviously it is not 0. This is 2 minus 3. That means this is minus 1. So this is also not 0. Okay, this is 2 minus 2. Yes, so this is our answer. And let us calculate for this also. This is 4 minus 2, because for gas, for solid I will not take, I'll only take for gases. So 4 minus 2 is 2. So option 3. Yeah, perfect, perfect. But I'm trying to give you all the logics also, the theoretical logics as well, because if few students are not comfortable with the theory, so it will be sufficient for them to learn the theory also, attempt questions together also. Chalo. Moving to the next one, guys. For a reaction this at constant temperature, now you have to judge. Now you can obviously do it. So delta H minus delta U will be equal to delta NgRT. So just what is value of delta Ng for this? Sir, this is gas. So 3, I will not be taking 4 because this is not gas. So product is 3 minus, this is 1 and this is 5. So 6. So this is minus 3. So it will be minus 3 RT, option 2. I hope everybody confidence aa raha hai beta. Yes, practice will always bring confidence. Good beta, I'm happy. Moving to this one. This is the next one. Moving to this one. Now the question says the maximum work obtained by an isothermal reversible expansion of 1 mole of an ideal gas at 27 degrees Celsius as in 300 Kelvin. From this to this liter, so this is change in volume, is now maximum for a isothermal reversible process. Sir, for a irreversible process external pressure is 0, but for a reversible process external pressure is not 0. It becomes a variable, therefore we integrate it. You do not have to do that in the examination. Just remember the conclusion, which is work reversible is equal to minus 2.303 nRT log of final volume upon initial volume. A very important formula, guys. Now you just have to put values into this formula and you will be getting your answer. So work reversible will be equal to minus 2.303 as in 3, because we are obviously having options, into what is the number of moles that the question is giving me, 1. What is the value of R? Sir, R is given in calories and work is also supposed to be calculated in calories, so value of R will be 2, into temperature is 27 degrees Celsius, therefore 300 Kelvin, into log of final volume is 22.4, initial volume, so V2 by V1 is 22.4 upon 2.24, as in it will be equal to 1 by 10. I hope everybody is clear. Okay, I'm sorry, not 1 by 10. This decimal will go, so it will be 10. So this will be log 10, and log 10 is definitely 1. I hope everybody is comfortable with this. Now, once you solve, yeah, perfect. So Hassan, we have Hassan with us. So Hassan has calculated this for us, and definitely he's right as well. Okay, Saif has also calculated this for us. So now this is just a calculation. I'm not saying it is easy. You will only be doing calculations with confidence once you practice today. Yes, so great. We have many students answering correctly. Sir ji, आप अंग्रेज हो क्या? हाँ हाँ beta, common sense, yes. Moving to the next one. But these comments are good. I mean, how we are going to enjoy in a room by such comments only. Chalo. So I love reading those comments. Chalo, moving to the next one. Quick. I'm not using poll. I have a home studio, na, and my home studio in a very small district. So even Paul knows this is a small district. Let me not work. It will not hamper, because ultimately we are wasting time by doing that poll. You can hit that comment screen, but yes, for that we need exclusive environment. And here my job back in J channel also, PWJ English, I was doing this only. Whenever we used to take live, I used to be so much connected with my students that we never use these polls and all. I force my students with my comments, and therefore they communicate also. So good. But yes, you keep on solving. UP 53 से हूँ sir. Okay, UP 53, perfect. Code word of RTO. I am close to UP 70. Chalo. 70, 72. Chalo. Saif. Perfect, guys. I need answer. Quick. UPMP rocks what? Chalo, moving to the question. 2 moles of an ideal monatomic gas are allowed to expand adiabatically. Sir, adiabatically as in Q is 0, and reversibly as in, again use the formula of reversible work, the work done in the system. Now here the question is supplying you with CV. So you are going to calculate work reversible. So it will again be equal to minus 2.303 nRT, because temperature, okay, it is, but the temperature, beta, we use this formula when temperature is constant. So because they are changing the temperature, so we can't do that. Then sir, what shall we do? Float first law of thermodynamics. First law of thermodynamics says delta U is equal to Q plus W. If Q is 0, then use such a function which is not path dependent. Then I'll calculate work. So work will be equal to delta U, and we know that delta U is equal to NCV, change in temperature. So how many moles we are talking of? 2. Heat capacity is given at constant volume, so it is 12.5 joule. I need value in joule only. Okay, I'll be converting by 1000 because answer is in kilojoule, because I want answer in kilojoule and this is given in joule, into delta T. So from this to this, so whatever it is, final minus initial, because delta U is a state function, so whatever it is getting finally, you will put that as final minus initial. So this is my final value, this is my T final, and this is my T initial. So 200 minus 300 will be minus 100. I hope everybody is clear with this. We are always putting final minus initial. So your answer will be, this is gone. 12.5 into 2 is 25. 10 will give 2.5. So this is minus 2.5 kilojoule. So answer is 2. Good. Perfect, Hassan. Kya baat? Perfect, Hassan. Good work. Moving to the next one. Again. Work. Arth, Pathak ji, perfect. Natakal, no. Chalo. Now, next question. Attempt. Although I started in NEET channel from yesterday, but I guess the response is good, beta. You people are serious. God bless you for your paper. God bless you. You will be doing great. God bless you. Seriously. If you're working for yourself now, then you are going to get whatever universe has best prepared for you. But yes, in order to reach to that level, you have to work for yourself. God only help those who help themselves. So at least help yourself, beta. Be serious, not for anybody else, but for you. Yeah, perfect. We have got answer. Hassan is perfect. Chalo, perfect. So this is a logical question. Negative entropy. Now entropy is S. Entropy is degree of avarapan, randomness. Solid is highly ordered, so has least entropy. Liquid entropy increases, gas entropy increases to the maximum. So gas changing to liquid, sir, gas has very high entropy, so obviously here entropy will decrease. So this will be your answer. Good bit, everybody is good. Moving to the next one. Yeah, attempt this one, guys. Perfect. Now, the enthalpy of vaporization. Now we have moved to thermochemistry beta. The enthalpy of vaporization, thermochemistry as in relating to entropy change of the processes. So dynamics also, but yeah, mixed with thermochemistry as well. Okay, perfect. I am Ishu. Okay. Hey Ish, okay, people are socializing. Hey, don't socialize here. Socialize by entering a decent government medical college. Socializing there will be more effective in every sense. So don't socialize here. Go to a proper government college and then socialize. The enthalpy of vaporization for water is this much. This is delta H, vaporization. The entropy of its vaporization will be, now sir, whatever may be the solvent, what does vaporization mean? A solvent, a liquid solvent getting converted to a gaseous solvent. We know that phase transformation takes place at a constant temperature. That constant temperature will be boiling point. I hope everybody knows this. Now delta H for the process is given to us, sir, then we should definitely know that entropy change of the system is equal to heat exchange between system and surrounding, because it is happening at constant temperature, so it will be equal to QP upon the constant temperature where it is happening. Now we know heat exchange between system and surrounding at constant pressure is equal to delta H, so this will be equal to delta H, which is vaporization in this case, upon the constant temperature. Here we are supposed to calculate the entropy change, so delta S will be equal to 186.5, it is kilojoule, so 10 raised to power 3 upon, okay, answer is also asked in kilojoule, so you do not have to worry about writing this because answer will be in kilojoule only, option is given. And the temperature, okay, so this solvent is water, so what for water TB is nothing but 373.15 Kelvin, that is 100 degrees Celsius. So now this is just a matter of calculation, I guess. This is double only, so most preferred option is 1. I hope everybody has got the answer. So that is approximately double. This is 1 by 2. So answer is, I mean, I guess there is an option problem because both the options are same. So let's say this is 1.5. So this will be 2.5. Let's say this is 3. So obviously you have an answer as perfect. Perfect, Hassan. Moving to the next one, guys. Attempt this one. Now, the question says 5 mole of an ideal gas expands reversibly from volume 8 decimeter cube. 1 decimeter cube is 1 liter, so the unit is liter only, at a temperature this much. So you have to calculate the entropy change. Sir, entropy change for a ideal gas, if at all you have some variables, then there, yes, you can derive it also, but beta, this is not the right time to have all those derivations. So I'm giving you a conclusion. Kindly remember this and update your formula sheet. So internal entropy change for any ideal gas generally can be calculated with the formula of NCV delta T plus NR. Okay, not delta T, NCV ln T2 by T1. It is NCV ln T2 by T1 plus NR ln V2 by V1. I hope everybody is with me on this. Kindly remember such calculative formulas, beta. If you try to recollect and derive these formula in your examination, then you will be taking time and the paper is gone for you. So at least keep these formula in your formula sheet so that you keep them in your head all the time. Now, so 5 mole of an ideal gas expands reversibly from this much volume to this volume, as in this is V1, this is V2, and temperature of, that means temperature is constant. So because temperature is constant, that means T1 will be equal to T2. So this will be log ln of 1, and ln of 1 in this particular case, in this case it will become 0. Here it will become 0. So delta S will be equal to, because log 1 is 0, so this factor will be 0, but this factor will have some value. How many moles I'm having? 5. What is the value of R given? Because I have to calculate in joules, so R will be 8.314. Some people use 25 by 3 also for the case of simplifying their calculation, into ln, so 2.303 into log of, because ln of x is equal to 2.303 log of x. So 2.3 into log of, what is V2? 80. What is V1? 8. So this will be log 10, which is 1. Now you just have to be good with your calculations, and once you calculate, yes beta, perfect. Obviously we can see values coming out to be positive, so it can't be any negative value, and once you'll solve it, I guess students are answering also. Yeah, perfect, safe, perfect, safe. Answer is 3. Good, good, good. Now, I hope the formula helped you, and I hope you can take this formula in your formula sheet and in your head till your D-Day examination. So that was a general formula for entropy change of an ideal gas. Perfect, 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 everybody. Moving to the next one. Now, this question, again, an important topic. Why important? Because here I am dealing with the spontaneity of the process. Sir, what thermodynamic parameter deals with the spontaneity of the process? Sir, I am not safe. I am Fatima. Okay, Fatima, I beg your pardon, but your name is written safe. But okay, so you must be using some other ID. Okay, Fatima. Chalo. Now, my spontaneity of a process. What is the thermodynamic variable that deals with the spontaneity of the process? Sir, it is delta G, and delta G, which is Gibbs free energy change, can be written as a delta H minus T delta S. Okay, so what in the reaction is spontaneous at all temperatures. So if I want this any process to be spontaneous, if I want any process to be spontaneous, then value of delta G should be negative. I hope everybody know this. Now, if delta G has to be negative, that means delta H minus T delta S as a whole has to be negative. Now, obviously, sir, it will depend upon temperature, but question is saying it should be spontaneous at all possible temperature. That means this value has to be negative. So if this value has to be negative, then how can you make it independent of temperature, sir? If delta H is always negative and delta S, which is always already having a negative sign, so if this change is always positive, then whatever hell be the temperature, my delta G will always be negative. So this should be negative and that should be positive. So delta H must be negative and delta S must be positive. So option 2 will be your right answer. Perfect, perfect. So very important conclusions. You must have seen this table on NCRT. So that table, I have revised that table with just a single question. So see how these questions are helping you learning theory also, attempting question also. But yes, revise, keep them in your head. Moving to the next one. Yes, attempt get this one, guys. The question says, for a reaction taking at 300 Kelvin, A and B are reacting to produce C. Okay, sir. Delta U is given in calorie. Delta S is also given. You have to calculate delta G. Sir, you have already told us the formula. Delta G equals delta H minus T delta S. But sir, delta H is not given. No worries. Delta H, we know how. So delta H is equal to change in internal energy change plus change in pressure volume work minus T delta S. That will be equal to delta G, and we are supposed to calculate delta G only. So let us work on the, can we expect these question beta? You can definitely expect the concepts. Definitely expect the concepts. Whatever questions I'm taking, whatever concepts I'm using, definitely attempt, definitely not expect, they will be there. What you have to do differently, into divide. How to do into divide? Once you recollect the formula and put these concepts in your paper in the time of your examination. So the only variable over here is time. And keeping the concepts here and reproducing them inside in your fair copy, in your rough sheets that will be given in your, don't take those rough sheets inside the NEET examination. No, not even this much of bit of paper, because they have gone really strict these days, hai na? Please tell your name. I am a new student of your class, but student of PW. Okay, Hassan, my name is Gaurav Singh Arora. You know, when I am a pass out from NIT Kurukshetra back in the year 2011, I passed out. I entered at 2000 in the year 2007. This was a thing that we used to do in ragging. Hey, what's your name? After first year, and we had an awesome experience while giving ragging. While taking ragging, I used to come to my hometown because I mean, after every 2 or 2.5 months, I have to come back to my hometown from college only during that time. But yes, once you now these days, but I'm telling you, ragging connects seniors with juniors in such an extent that they remain mentors throughout their life. But there are some disadvantages as well. But okay, chalo. Nevertheless, moving to the logic. So delta U is given to us. How much delta U is given? -3 kilocalorie, and all the answer is in calories. So I'm converting into kilo as in 1000. So this is -3000 is the value of delta U plus P delta V. Now the question is saying this is a chemical reaction. So this P delta V and temperature is constant. So this P delta V can be written as delta Ng RT minus T delta S. T is 300 and delta S is also given -10. So this is plus and a 0 will also come. So this 3000 will be getting cancelled. So I am left with only this. So delta Ng for this reaction is 1 minus 2. So this is -1. So this is minus R. R is 2 in calorie and temperature is 300. So this is -600. You just have to be informed about your logic, and obviously you will be landing with your answer. Perfect, 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 everybody. Moving to the next question. I heard some noise. So attempt this one, guys. By the time I just see what voice I'm hearing. Acha, nothing much. Chalo. I hope we are working fine. Chalo. Chalo. Moving to this one. Answer, guys. Now, the value of delta H and delta S for the reaction this. So, this is a chemical reaction and delta H is given out to be minus 100 kilojoule. Delta S is also given out to be minus 100 joule per Kelvin. Beta, make sure that you pay attention in the unit given. This is kilojoule and this is joule. Students miss this. In the previous question also, the kilo thing will be hampering you for the calculation respectively. The reaction will be spontaneous at, sir, because it's a reaction, so reaction spontaneity is decided by delta G. So delta G has to be negative. It can be negative when, sir, this depends on the value of delta H and delta S. The question is saying delta H is negative, so this value is negative, but this value is also negative, so collectively this will become positive because minus minus will become plus. If I need delta G to be negative, then I want this positive magnitude to be less. That means reaction, this process or reaction will be spontaneous at what? At low temperatures. I hope everybody is clear with this. I'm just using the same logic. So it will only be spontaneous at low temperatures. So that means because they are asking the option, so choose a temperature which is low. You do not even have to solve. You do not even have to solve. So answer will be 2 because I've told you the sign convention. Sir, if you need delta G to be negative, so it will only be negative when this magnitude is less, which will be positive in this case. So, what is the operator to make this factor less in magnitude? Sir, keep the temperature low. So choose the lowest temperature and you will be having your answer. Perfect. Chalo, moving to the next one. Beta, 1000 will be the temperature when it will be at equilibrium, and at equilibrium delta G is 0. So you can obviously calculate that temperature when it will be 0, but that will be 1000. So at 1000 it will be at equilibrium, not spontaneous. So you have to choose a lower temperature than that temperature of equilibrium. I hope everybody is clear. Safe. I hope we are clear. Mental दोनों हेल्थ खराब हो गई. Random क्यों भाई? Beta, is physical chemistry not coming in your NEET examination? It is. Are you not sure, or are you not willing to enter a government medical college? You want your parents to pay crore of rupees for your MBBS degree? No. Then buy question 1 and 2. Please pay interest. Chalo, moving to the next one. I hope it is clear to everybody. Chalo. Next question, guys. This one. Attempt this one. Okay. So I guess we should move to chalo. We should move now. The reaction, the heat of reaction for this is given. So this is delta H for this reaction, and for this reaction also, let's say this is delta H1 and let's say this is delta H2. The heat of reaction for this reaction, sir. Now we have come to thermochemistry, and thermochemistry says that enthalpy is an additive. If you it is an extensive quantity. What is an, I mean, yes, all the thermodynamic properties are extensive, and because they are extensive, if you add two reactions, they will also be added. If you subtract two reactions, they will also be subtracted. If you multiply a reaction by any variable, they will also be getting multiplied because they depend on amount. Because thermodynamic variables are generally dependent upon the amount present in the system. I hope everybody is clear with us. Yes, in order to make them intensive, we use their molar value. but in general, by their property, thermodynamic properties are extensive. That is, they depend upon the amount that you have taken in the system. So can you construct this reaction using the given reactions? Yes, sir. I need A in the reactant and I need AO2 in the product. So if I add both these reaction 1 and reaction 2, I guess you will be getting this reaction. So for this overall reaction, how you are constructing them? By adding the two reactions, so the enthalpy will also be getting added up. I hope you can see this. One enthalpy is given out to be minus 50, other one is given out to be plus 100, so answer will be plus 50. I hope everybody is clear. Yeah, perfect. Good one. So with this, we have moved to thermochemistry. That means attempt this one, guys. Now the question says, which of the reaction defines molar enthalpy of molar but standard enthalpy of formation? This not sign means standard enthalpy. So what is enthalpy of formation? Enthalpy of formation is the enthalpy change of a reaction when 1 mole of a product is formed from its constituent elements in their most stable state. So do I have 1 mole of compound? Yes. Calcium carbonate is formed from its no, sir. Constituent is calcium, not calcium oxide. So because the elements are not in their standard state, so this is not enthalpy of formation. 1 mole is forming? Yes. Elements are in their standard state? No. Only the state. Bromine is present in liquid state at normal condition, and because it is saying gaseous, so that is also not standard state, although the molecular composition is good. It is in sync with the standard state, but the physical state is not in sync, therefore it is not in its standard state, therefore not an answer. Do I am forming 1 mole of compound? Yes. What is the standard state of nitrogen? Nitrogen gas, perfect. For hydrogen, hydrogen gas, perfect. For oxygen, oxygen gas, perfect. Yes. So the enthalpy change when 1 mole of a compound is formed from its constituent elements in its most stable state, reference state, standard state, is enthalpy of formation. Here 2 mole is formed, so this is also not an answer. Obviously, we have got our answer. Moving to the next one. Attempt this one, guys. Now, for the reaction, this delta H is given. If the enthalpy of formation of SO3, okay, enthalpy of formation of SO3 is given, then you have to change enthalpy of formation, calculate enthalpy of formation of SO2, and delta H is given. Now, this is just an application of thermochemistry. The important conclusion is enthalpy change of any reaction can be calculated using enthalpy of formation. How? It is equal to summation of enthalpy of formation of products into their stoichiometric coefficient, that's why I'm writing that I, minus summation of enthalpy of formation of reactants. So this is final minus initial, but final of what? Enthalpy of formation of product minus reactant. So how to calculate the enthalpy of reaction is given for this process. So this is minus 98.3, because answer is also in kilojoule, so we'll not bother about the kilojoule over here. So this is enthalpy of reaction. It is equal to enthalpy of formation of product, which is SO3. For SO3 value is given, only 1 mole of SO3 is there, so 1 into minus 395.4, this is of product minus reactant. Of SO2 we have to calculate, so enthalpy of formation of SO2, how many moles? Sir, 1 moles. Enthalpy of formation of oxygen will be 0 because it is in its reference state, so you just have to do into divide, and I guess you will be landing with your answer. So what answer, guys, we are getting? Obviously it will be a negative value, and I guess once you solve it, yeah, mathematics is crucial. It is actually going to make the difference because logic is going to repeat. The only thing is whether you are going to do the mathematical calculations with a calm nerve or not. If not, you are going to land with a negative mark. Sir, but I want to attempt it properly. Please give me a trick to do plus minus. There is no trick. The best and the foremost trick is to attempt religiously right now and keep on doing this. gradually it will change, sir, but we have only 3 days left. Whatever marks you are going to get, at least you may score one question more with this practice that we are doing right now. So do that, and obviously you'll be landing up with, yeah, perfect. Many of the students are getting one perfect, guys. Next one, attempt this one. The question says the enthalpy of combustion of carbon and carbon monoxide are given. Now I am giving, what is enthalpy of combustion? The enthalpy change when 1 mole of a compound reacts with oxygen and form its stable oxide. The enthalpy change of such reaction is called enthalpy of combustion. Obviously it is also exothermic, but if you utilize the enthalpy of combustion, then you can also generalize the enthalpy of reaction definition as well. What is it? A very important conclusion. In JEE mains also, they have asked this a lot of times, and I am telling you it is a very important conclusion for your NEET examination also. What is the conclusion? Enthalpy change of a reaction can also be calculated, not it can be calculated using enthalpy of formation. We have seen product minus reactant. But if you are given with enthalpy of combustion, then it was equal to summation of enthalpies of combustion, but into their stoichiometric coefficient, but very important because students miss this, of reactant minus product. For formation it was product minus reactant. For if enthalpy of combustion is supplied to you for the species, then just directly do the difference in enthalpy of them, but reactants minus product, not otherwise. So sir, if we remember this, can we solve the question? Let us try. Now the enthalpy of combustion of carbon and carbon monoxide is given, and you have to calculate enthalpy of formation of carbon monoxide. Okay, enthalpy of formation of carbon monoxide. So what is carbon monoxide? CO. Enthalpy of formation, as in I have to calculate, I have to form 1 mole of carbon monoxide. Carbon monoxide has what element? Sir, it has carbon and it has oxygen. What is enthalpy of formation? Formation of 1 mole from its constituent in its most stable state. So most stable state of carbon is carbon solid. Most stable state of oxygen is O2 gas. But because I have 1, so this will be half. This is my enthalpy change of formation, which is in this case enthalpy of reaction also. And enthalpy of reaction can be calculated by enthalpy of combustion also, reactant minus product. So who is my reactant? This. So for carbon solid, what is enthalpy of combustion given? Combustion given is minus 393.5 into 1, because stoichiometry is 1. This is of reactant, plus half of, because I have a stoichiometric coefficient. For oxygen, how much it is given? Acha, sir, carbon can react with oxygen. Oxygen can't react with oxygen, so obviously it will be 0. Obviously it will be 0. So not considered. Minus. So this is reactant minus product. So this is enthalpy of combustion of carbon monoxide is also given as minus 283 into 1 only, because coefficient is 1. So this is our product. Just solve this, and I guess it is pretty easy. People are doing it also. Option 4, good one. Yeah, so if you solve, you will be getting option 4 as your right answer. Moving to next one. Yeah, attempt this one, guys. Yeah, perfect. Sir, NEET 2026 is expected to be tougher. So it will be at this level or tougher than this. Beta, this is not easy, I would rather say. This is good, not advanced level. I mean, yes, we take good, very, very good questions in for JEE Advanced, but yes, for a mains level of paper, yes, it will be matching JEE level. So that is what we are expecting also for physics, for chemistry, for both. And yes, as engineers, we obviously feel bio is quite doable, but I know after seeing Ambika ma'am's class, I can definitely say it requires huge amount of energy. But yes, I would definitely say that you must be spending that much of focus in your, because obviously bio is altogether 90 questions, botany and zoology. So physics, chemistry is going to make the difference in your, whether you're getting a government college of your choice whether you're getting a government college not of your choice, maybe very far away from your place, whether you're not even getting it, you even have to manage with a private engineering college, a private medical college. The difference is made by physics and chemistry. You have to be in sync with it, because students generally are comfortable with scoring good in botany and zoology. So yes, you have to make that choice, you have to make that decision, and you have to make that extra efforts also, guys. Come on. Moving to this question. The question says, heat evolved in the reaction, this is this much. Bond energy. Now, the other type of reaction, the other formula of enthalpy of reaction is what? The enthalpy of reaction can also be calculated as summation of bond enthalpy. Now, this is the third thermodynamic variable, a third type of enthalpy of reaction. If in the question bond enthalpy is given, then you calculate bond enthalpy as per the stoichiometric coefficient, but again of reactant minus product. So this is also reactant minus product. Combustion is also reactant minus product. Bond enthalpy is also reactant minus product. Enthalpy of formation is product minus reactant. I hope everybody is clear with this. Chalo. So enthalpy, heat evolved in the reaction is given. Heat evolved. So because heat is evolved, therefore the delta H value that is given should be in minus, with a minus sign, because it is saying evolved. So this will be minus 182 kilojoule because it is getting evolved. So this is delta H will be equal to bond enthalpy of H2. So delta H of H bond H plus delta H of Cl bond Cl, because stoichiometrically it is also 1, so this is bond enthalpy of reactant minus product. So I have H bond Cl. The bond enthalpy of Cl is given, HH is given, and you have to calculate. Okay, this you have to calculate. So this will be twice of delta H bond enthalpy of H bond Cl. Now this value, what value? This value you have to calculate. Let's say this value, for the case of simplicity, I'll be writing as A. So minus 182 is equal to, what is H bond H given? 430. Plus, what is Cl given? 242 minus 2A. This A I have to determine. So 2A will be equal to, add this is 2, 4 and 3 is 7, 4 and 2 is 6, and this will be added, so 182. So 2A will be equal to 224, 8 and 7 is 15, this is 8, so this is 4, then 2, then 7, so this is 427 kilojoule. I hope everybody is clear with this. सर लेकिन बॉन्ड तोड़ने में हाफ इंटू डेल्टा एच का लगती है नहीं बेटा. That you are thinking from Born-Haber cycle. Over there, like for example, I need to form NaCl. And if I'm breaking Cl bond Cl, then if I break Cl bond Cl, if I break 1 mole of Cl bond Cl, I will get 2 atoms. So that's why, but for the formation of NaCl, I need only 1 chlorine atom. That's why in that Born-Haber cycle calculation, we do that half thing. But I hope you are getting the logic why you're doing that half thing. I'm answering Abhinav, Abhinav Mishra. Abhinav, I hope you got the logic why that half is there and why here I am not supposed to do any half, because ultimately this reaction is balanced. So the half thing I have not done over here, but the multiplication too I am doing over here. Why? Because this is the stoichiometry. So I am going as per my stoichiometry only. I hope, but that half thing is clear to you. Perfect guys, perfecto. You guys are super awesome. Good beta. I love being with serious students. Thank you. Chalo. No, do not thank me beta. I am thanking you. We as a teacher has no existence. We are nothing. I am nothing if I am not able to help any of the student life. So we exist because of you. And whenever we are, I mean, any and every day, if I am able to help one student, two student, maybe more, a day is made. I feel super awesome whenever in the beginning of the day on the class in the morning, even if whenever I'm having a class in the morning in my batch class, I mean the PW app classes also. So whenever I see this comments, my day is made. So but you have to keep working keep working well for yourself. Chalo, next question. Question 2. Question 2. Acha, okay. We have came to equilibrium, beta. With this, we are starting chemical equilibrium. With this, we are starting chemical thermodynamic. We are starting chemical equilibrium. So the first question says, for a reversible reaction, the rate constant for forward and backward reaction are this and this. That means this is value of Kf. This is value of Kb. So what shall be the value of equilibrium constant Kc? Sir, it is ratio of Kf upon Kb. So you just have to do the ratio, and once you do it, I guess 2 will be your answer. So I'm moving quickly from here now, because I guess we have to finish equilibrium in in less than an hour, because then we'll be taking a 15 minutes by break. Bio break, lunch break, है ना? And then we have to start with 12 physical chemistry, electrochemistry and chemical kinetics. Electrochemistry will be taking a bit of time, but yes, because it is logical also, it is good also, and electrochemistry I feel is a chapter which is going also, because maybe these things many students do. Electrochemistry is a topic which only government medical college going students do. So I will I'm separating that electrochemistry separately. So can you explain the previous one? Beta, I did. See, equilibrium constant Kc is ratio of forward and backward rate constant. So Kf is the ratio of Kf by Kf by Kb, because what is equilibrium? Whenever reactant get exist in equilibrium with product, rate of forward reaction as per law of mass action is equal to Kf into concentration of reactants raised to the power stoichiometry, and rate of backward reaction is equal to Kb into concentration of product raised to the power stoichiometry. It may be X, it may be Y, whatever is the stoichiometry. Let's say this is X, this is Y. At equilibrium, both of them are equal. So once you equate them and you write the concentration of product upon reactant, you get a ratio of Kf by Kb, and that Kf by Kb we write as Kc. So Kc is nothing but Kf by Kb. I hope everybody is with me on this. Just do the ratio and you will be getting an answer. है ना? चलो. Moving to this next question, at a given condition, the equilibrium concentration of species are given. The equilibrium constant can be calculated. Now, as I was saying, that equilibrium constant K, which is ratio of Kf by Kb, is actually concentration of product or upon reactant raised to the power stoichiometry. So let us write the reaction. So the reaction is okay. The reaction is already written, and we are having their equilibrium concentration. For H2, it is 0.8. For I2 it is okay. For HI it is 0.8. This is 0.8. For H2 it is 0.1, and for I2 it is again also 0.1. So value of equilibrium constant Kc in terms of concentration is written as concentration of product raised to the power stoichiometry. This concentration should be concentration of equilibrium upon concentration of reactants at equilibrium. So reactant is H2 and I2. Stoichiometric coefficient is 1, 1. Now exact values are given. So yes, but you have to be quite quick with your calculation, so kindly calculate. You just have to put the values. So HI is 0.8 squared upon 0.1 into 0.1. So this is just per decimal. I mean, yes, this is the calculation is also very doable. I hope everybody is clear. And I guess this is a NEET archive beta. This is an exact NEET question. So yes, you will be having a good time if you get such easy calculations in your paper, and you do you get some typical also, but you get some easy balls also. So play them well, which you can only do once you are full with confidence. Chalo. Moving to this next question, which says, which says for a reaction this Kp and Kc. Now a very beautiful relation. What is the relationship between Kp and Kc? Sir, Kp as an equilibrium constant in terms of partial pressure is equal to Kc as an equilibrium constant in terms of concentration. Is Kp is equal to Kc into R as an universal gas constant into T as in temperature in Kelvin raised to the power difference in gaseous moles of product and reactant. A very important conclusion. So what shall be ratio of Kp by Kc? Sir, it will be RT raised to the power delta Ng, which is product minus reactant. So product, I have 1 gaseous mole, minus reactant, I have 2 gaseous moles. So this will be -1. So answer will be 1 upon RT. Perfect. Perfect. Moving to next one. Now, consider the following reactions. A very important conclusion, beta. Once you add two reactions, equilibrium constant get multiplied. Once you subtract two reaction, equilibrium constant gets divided. Once you multiply a reaction by any factor n, equilibrium constant gets that factor in its power. I hope everybody remember this. Okay, let us do this with an example. Yeah, perfect. Perfect, Abhinav. Now, this is first reaction, this is second reaction. You have to give relationship between K1 and K2. Now, how can we convert first reaction into second reaction? First of all, here reactant is A2B2, here product is A2B2, so I have to reverse the reaction. So, K2 is the final reaction, so final equilibrium constant will be equal to. First, I have to reverse the reaction. In order to reverse the reaction, I have to multiply the reaction by -1. So K1 raised to the power -1, that I have to do only. So K1 raised to the power -1 will reverse the reaction. But if it is reversed, it will become 2 here. But here it is not 2, sir. Sir, it is 6. That means I have to multiply by 3 also. So the power will be multiplied by 3 also. So K2 will be equal to 1 upon K1. Okay, this is I mean, you do not have to do anything after this, beta. Once you know this, you get the answer. No mathematical justification required. But yes, important conclusion. This is characteristic of equilibrium constant K topic. I hope everybody got that. Perfect. Chalo. Moving to this question, guys. Attempt. The question says a reversible reaction having two reactants in equilibrium. If the concentration of reactants are doubled, then equilibrium constant. Sir, value of K only depends upon temperature. You keep on doing anything. Value of K, yes, the equilibrium may get disturbed, but it will again re-attain equilibrium. After getting disturbed, apply Lee-Chatelier's principle, it will again get back to its original state. So value of equilibrium constant only depends upon temperature. It do not depends upon the concentration of the reaction mixture and the pressure of the reaction mixture. Therefore, it will remain the same. I hope everybody is clear. Chalo. Moving to next one, for the reaction this, the unit of Kp will be. So sir, again, Kp is equal to equilibrium constant in terms of partial pressure. So partial pressure of product upon partial pressure of reactant. So partial pressure of product as in this is stoichiometry 1, this is stoichiometry 2. So what, let us say unit of pressure is atm. So atm raised to the power delta Ng will be your unit of Kp. What is delta Ng? Sir, this is 4 minus 2. So product minus reactant. So this will be 2. So option is 2. I hope everybody is clear. Now, next question. If value of an equilibrium constant for a particular reaction is this. Now, again, an application of equilibrium constant. Sir, temperature, stoichiometry dependent. Perfect. Now, beta, if value of K is large as in it is greater than 10 to the power minus 3, of the order of 10 to the power minus 3. In such cases, we say K is very large. What is K? Concentration of product upon reactant. That means concentration of product at equilibrium is very, very large than concentration of reactant at equilibrium. If K is 1, then equilibrium concentration of reactant and product are equal if K is less than or of the order of 10 is power minus 3, then this means concentration of product at equilibrium is very, very less. And in fact, the reaction is not at all moving forward. At equilibrium, you have practically all the reactant, only very few product is produced. That means a reaction which is not at all going in forward direction. So because in this question K is large, so what will be present at equilibrium? It will be mostly products. Perfect. Perfect. Moving to the next one. Attempt this one, guys. Consider this reaction. The value of equilibrium constant for reaction is given. Okay, so you are given value of Kc. And this is value of K. It was observed that concentration of 3 species is this much at equilibrium at a certain instant. Okay, so this is concentration at any time t. Discuss what will happen to the vessel. Okay, so this is concentration at any time t. Sir, if I know concentration at any time t, then I can calculate that the reaction is at which state. Like for example, the track represents value of K. Your reaction is like a ball. Value of K is dependent upon the track. Value of ball is decided by the value of Q. At equilibrium, Q is equal to K. If Q is less than K, then reaction will proceed forward. If Q is greater than K, then reaction will proceed backward, because ultimately ball or reaction wants to attain the lowest energy point, which is the equilibrium point. I hope everybody is clear. Now, that's why I am saying that K is not dependent upon what is the ball, what is its concentration pressure. Ultimately, you are a solid ball, you are a rubber ball, or you are whatever ball, you are a woolen ball. You will have come to me. I have no business what is your what is your material, what is your concentration, what is your weight. I hope you are getting that. K only depends upon the track, as in temperature and the type of reaction. Chalo. So let us calculate Q, which will also be calculated in the same fashion as K, but the values will be taken of any variable point T, like we are having over here. So this is concentration of SO2 Cl2 upon this. So all of them have same concentration. So concentration of SO2 at time t, concentration of Cl2 at time t, upon concentration of SO2 Cl2 at time t. So every concentration is given out to be same. So let us cancel one. So Q will be equal to any concentration, that is 0.05. If I compare it with K, then I can definitely see this 0.05 is a large value than K. That means scenario is not like this, scenario is like this. So where ball will proceed, so reaction will proceed in backward direction. I hope everybody is clear. What is your conclusive answer for this? Reaction will proceed in backward direction. There is no one ABC 1 2 3 over here. This is a theoretical question in which I am explaining to tell you how to determine that whether what will be the direction of a reaction. I hope everybody is clear. Moving to next one, guys. Attempt this one. Good, good, good. Attempt this one. The question is saying that Lee-Chatelius principle is not applicable. So again, now the final side of chemical equilibrium, then we'll be plugging to ionic equilibrium. So Lee-Chatelius principle is not applicable to, sir. Lee-Chatelier principle, as in whenever you disturb an equilibrium, it will try to reattain it. So which reaction you cannot disturb the equilibrium? Sir, here this is 1, and this is 2. So here delta Ng is 0. So if I disturb this equilibrium, if at all I try and disturb this equilibrium, but yes, it may get affected beta. Because delta Ng, if I increase concentration of reactants, reaction will be disturbed. So no, we can't do this by delta Ng. Acha, I have a solid over here beta. Pure solid and pure liquid have no effect on the equilibrium state. I hope everybody remember this. Every other case you have gas, therefore it may change. So pure solid and pure liquid do not. Therefore your answer for this question will be option 2. Yes, a tricky one, but yes, a good one. Moving to the next one. Attempt this one, guys. I hope everybody is clear with the previous question. Attempt this one, guys. Let me sip some. Attempt this one, guys. Anyone free here? Okay, Abhinav is answering. Let us also check. For a reaction, I hope I'm audible. Yeah. Now, no one is free here. No, no one is free here. Everybody is working over here. As PW Arjuna NEET in English class. Yes, Akshay. Arjuna NEET English is going to start soon. Now, for a reaction, because obviously heat is acting as a reactant, so if I increase the concentration of reactant, reaction will get disturbed, and in order to reattain, I will oppose the change. So because I'm increasing concentration of reactant, so reaction will proceed in forward direction to decrease. And because it is endothermic process, so for an endothermic process, heat will be absorbed, so it will be taken as a reactant. So if we increase the temperature, reaction will proceed in forward direction, and therefore the concentration of product will definitely increase. Everybody is correct. Moving to the next one, guys. Attempt this one. Yeah, perfect, Abhinav. Chalo. Next one, guys. Okay, Robin. Let's see. Now, this question says, which of the following equilibrium is not shifted by increase in pressure? Now, if you change the pressure, reaction will, whatever change, let's say I increase the pressure, so reaction will try to decrease the pressure to oppose it, and in order to decrease reaction, gaseous reaction will move in that direction where number of moles will decrease. So which reaction will be not affected? Now here, which will have delta Ng 0. So first reaction has delta Ng 0, so it will not be affected, while all the other reactions will be affected because they have some delta Ng value. I hope everybody is clear. Perfect. Attempt this one. This is a actually this is an NCRT logic, beta, and why I'm using this NCRT logic, because at least for those students who are not comfortable with the theory, I want to have you a quick hands on the NCRT logic, which you should know. Chalo. So the question says, what is the equilibrium concentration of each of the substance in equilibrium when initial concentration is of ICl is, so at time t equal to 0, concentration of ICl is 0.78 moles per liter molar. So this is nothing but this is initial concentration given. Now, initially what product I have? 0. Because some mathematical calculative questions will be there. I'm just doing this one question for each of those type of questions. Into divide, you can obviously practice back at home. Now, sir, this is my initial concentration. This is 0. This is 0. So how to do stoichiometry, sir? The stoichiometry that we have just learned yesterday. Sir, 2 mole of this reacts to form 1 and 1 mole of this. So let's say at equilibrium 2x amount of reactant is consumed. So how much is remaining? 0.78 minus 2x. 2 produces 1. So 2x will produce x. 2 produces 1, so 2x will produce x. So these are equilibrium concentration. And because value of K is given to us, therefore value of K, which is 0.14, will be equal to concentration of product, which is x into x, so x squared, upon concentration of reactant, which is 0.78 minus 2x raised to the power stoichiometry whole squared. Now I am not going to solve it. Yes, obviously you can solve it, but I am not going to solve it because this is exactly NCERT question, and obviously NCERT questions, as you know, because they have exact experimental values which actually exist in the physical life also. So the calculations are quite difficult, but yes, for practice you can do so. And sir, what we will get out of that practice, you will get the value of x. Once you get the value of x, you can calculate equilibrium concentration of all species. Concentration of I2Cl2 will be this x. Concentration of ICl will be 0.72 minus 2x. So in your ABCD type of questions, you will be asked one of the questions of this sort. I hope everybody is clear. Now, moving to next one. Attempt this one, guys. Attempt this one, guys. Now, this question says, I hope most few of you have attempted it. 3 mole of PCl5 kept in 1 liter closed vessel was allowed to attain equilibrium. Now, you first have to know the basic reaction also, because sometimes NTA hides it. So PCl5 having 2 axial chlorine, so they will be easily broken because axial bond lengths are larger. So it will be breaking into PCl3 and Cl2. This is the reaction. Now, 3 mole of this is kept at 1 liter. So this is nothing but concentration. What concentration? Initial concentration I'm having. Initially I would be having nothing of this. Now once it will gain equilibrium, so 3 minus x and x will be produced. Calculate composition. So this is the same question which I was talking of. Let me frame it again for you. So Kc is equal to 1.8. It will also be equal to x square upon 3 minus x. You will get a quadratic. Obviously you can solve the quadratic and calculate the composition of equilibrium mixture. So this will be x and this will be 3 minus x. You can solve accordingly. I hope everybody is clear. Yes, this calculation I'm not doing because this is a practice question for you, so that you can have a hands-on with the NCERT questions as well. Okay, chalo. Moving to again obviously a practice question for you. So the reaction is given when this much mole of NO and this much mole of Br2 are mixed in a closed vessel. So these are initial concentration. So at equilibrium, NO will be 0.087 minus X. Br2 will be 0.0437 minus X. And NOBr will be, the product will be 2X. The question is telling you this much of is obtained at equilibrium. So value of 2x is given out to be 0.0518. So this is how they can also, they are not now giving you value of K. They are giving you the concentration of the product. So ultimately you will calculate X. So now what do you have to calculate? Calculate equilibrium amount of, so once you know X, subtract, you will get equilibrium amount of both. So these are the type of questions. These are the type of questions that you may get in your examination, because these are some NCERT reactions. And yes, you at this point of time at least do them back at home for practice. So sir, but how will we get these notes? Once the class is over, you can download these notes for free. Just go to PW NEET English WhatsApp channel and it will be uploaded in that WhatsApp channel. Okay, chalo. Now perfect. Moving to the next one. Now moving to some NEET questions. There are framing of some questions which require the knowledge of degree of dissociation alpha as well. Like for example this, for a reaction this, the total pressure is given, the degree of dissociation is also given, and you have to calculate value of K. So how to do such questions? Now what is the pattern of the reaction? 1 mole of gas gives 1 and 1 mole of another gas. So this is 1:1:1 pattern. let's say initially I have taken 1 mole of this, because value of K do not depend upon the concentration or anything or moles of reactant. So why bother taking more variables? So if I've taken 1 mole of reactant, so initially I have nothing of these gases. At equilibrium, 1 minus alpha, because degree of dissociation is alpha. So if I'm taking 1, it will be much easier for me to calculate. So at equilibrium, if alpha percentage of 1 is getting dissociated, so this will be 1 minus alpha remaining, and alpha will be getting produced. But sir, these are moles, I need pressure. So value of Kp will be equal to partial pressure of them upon partial pressure of this raised to the power 1. Partial pressure is equal to mole fraction of this, mole fraction into total pressure. What is mole fraction? Some moles of this upon total. Total is this, which is 1 plus alpha. So this will be alpha upon 1 plus alpha. This will also be alpha upon 1 plus alpha. So it will be squared upon, this is 1 minus alpha upon 1 plus alpha. Now, what about total pressure, sir? Total pressure squared upon total pressure power 1. So you will get total pressure P. Now, you can also memorize this value of pattern of K, but yes, if not, then it will just take 20 seconds to solve. So you can obviously see this, the numerator has alpha square. This is 1 plus alpha squared, but 1 plus alpha will be cancelled. So in the denominator, I'll be left with 1 plus alpha. This is 1 minus alpha. So 1 minus alpha, 1 plus alpha will be 1 minus alpha square. And this is P. So this is my value. This is my relationship of alpha P and total pressure and Kp for a 1:1:1 mixture. One reactant producing 1 mole of gaseous product. Okay. People are answering also. Okay, let me just do it for you. So value of Kp, this we have to determine. Alpha is 50%, 50% is 1/2, so this is 1/4. Total pressure is taken as P only upon 1 minus 1/4. So this becomes 3/4. That means 4 and 4 is cancelled. So this is nothing but P/3. So answer is third. I hope everybody is clear. I hope everybody is clear. Chalo. Moving to the next one, guys. Now, again, the same process, but yes, now you have to do it 2 times, because this is your reactant, which is N2O4 dissociating, as in getting NO2, so twice of NO2. This reaction is not written, so you have to inorganically predict it now. So you have to inorganically predict it. Cars and bikes collection. Sir, repeat, beta. This is the same pattern of question. I'm doing the same thing again only. Don't worry. So this is getting produced. So 1 mole of this producing 2 mole of this. Let's say I started with 1 mole of this. Initially, I had 0 mole of this. So 1 minus alpha will be producing 2 alpha moles of this, because degree of dissociation is given. Total mole is this plus this. So 1 minus alpha plus 2 alpha. So this is also 1 plus alpha. So practically this is also 1 gas gives 1 gas plus 1 gas. So ultimately this is the same. And how to calculate value of Kp? We have already seen. Moles of this upon total moles into pressure raised to the power 2 upon moles of this, which is 1 minus alpha upon 1 plus alpha into pressure. Now pressure squared upon pressure to the power 1. So I have total pressure P, just 1. And in the numerator, I'll be having alpha square, and in the denominator, I'll be having 1 minus alpha square every time when I'm getting a composition of the form 1 gas giving 1 gas and 1 gas. I hope the student car, bike and saying again, this I've repeated again beta. Okay. Now, so here what we have to compare, now NO2 is dissociated to this much percent and this much percent if pressures are different. So I am taking different pressures, sir, but reaction is same. So value of Kp will remain the same. So Kp will remain the same. I just do this for 2 different cases. So what is the first case? At pressure P1. This will be what is at pressure P1, what is degree of dissociation? 33%. 33% is 30, let's say 33 upon 100. So this is 1/3 approximately. So alpha is 1/3. So this is 1/9 upon 1 minus 1/9. This is at state P1. this is equal to at state P2, because ultimately that also will be equal to Kp only, because value of K do not depend upon the whatever pressure you are taking. So P2 times of what is the sir 40 by 100. So 40 by 100 is 4 by 10. 4 by 10 is 2 by 5. So this is 2 by 5 as in squared, na? So 4 by 25, 2 by 5, na? So 1 minus 4 by 25. Yeah. So once you solve it, I guess you have to do, because I have approximated, na, 1 by 3. This is exactly, this is 33. So you just have to do that approximation and you will be landing up with 8 by 5. It will be coming out something different, but yes, you can approximate the value and you will be getting somewhere around this. So this will be your answer. Good. Good. Chalo. Perfect. Moving to the next one, guys. Yeah. Next question says, now moving to ionic equilibrium. Now ionic is very simple if you just be exam specific. So moving to ionic equilibrium. Those were the question from chemical side. Okay, moving to ionic equilibrium. Yeah, perfect, guys, perfect. Okay, perfect. Now, moving to ionic equilibrium. From the ionic side of equilibrium, first you have to know the definitions of acid, bases, and salts. So, first you have to know the definitions of acids, bases, and salts. So the conjugated acid of this, so that means acid of this, that means this will be base. So what is Bronsted and Lowry concept of conjugate acid base theory? Acid is a species which gives H plus, and base is a species which rather accept H plus. So because you are asked a conjugate acid of this, that means this will be a base. Base does what? Base accept H plus. So oxide ion present in a solution accepting H plus from the solution will form what? Sir, will form hydroxide ion. So this will be my acid and it will be its conjugate base. So if it is my base, that will be my conjugate acid. So my conjugate acid will be option 4. I hope everybody is clear. Okay, perfect, guys. Chalo. Moving to next one. Attempt this one. The beer has pH this much. What is H plus ion concentration? Array sir, beer has pH. So pH is what? pH is equal to minus of log of H plus ion concentration. What is property of log? So log of A to the base B is equal to X. Mathematically, this means B to the power X is nothing but A. I hope everybody's at least clear till this much. Okay. Now, if pH is this, then the value is given out to be 4.3. I am making you learn how to calculate NT log beta. So that means this is base 10. So this minus will go over there. So 10 raised to the power minus 4.3 will be equal to this log of A. That means H plus ion concentration. So this is how you can calculate H plus ion concentration using NT log common sense. I hope it is clear. Now, sir, how to calculate this? Beta, just go to the next integer. So H plus ion concentration will be minus 4.3. Magnitude wise, what is the next higher integer? Magnitude wise, not on the number line. Minus what is greater? Mathematically, what is greater than 4? 5. So 10 raised to the power minus 5. But sir, this is 0.3. No worries. 10 raised to the power. What should I place, sir? Some positive thing. How much? Sir, minus 5 plus 4.3. What is the difference? 0.7. I hope everybody is clear with this. So, but how we are going to calculate it? Beta, just learn one value. Log under root is nothing but log, 10 under root of 10 is nothing but 10 raised to the power 1 by 2 as in 0.5, which is 3.162. Just remember this. And 10 raised to the power 1, sir, it is definitely 10. And 10 raised to the power 0, sir, it is 1. That means 10 to the power 0 is 1. 10 is power 0.5 is this much, 3.162. That means how many steps I'm taking? 0.1, 0.1, 0.5 steps. So with 5 steps, I'm going from 1 till 3.16, 3.162. So every step is approximately taking how much? Every step of 0.1 is approximately equal to 0.4. Just add 0.4 in 1, approximately you'll reach 3 point something. And from here to here, every 0.1 step will be making you 1.3, 1.4. So keep on adding it and you will be getting some. You do not have to do this. Why? Most of the time, even the 10 raised to the power 10 raised to the power will give you the answer. Like for example, we definitely know power is 10 to the power minus 7, and this thing will be definitely an integer in, because this will not be 10, so this will be between 3.162 and 10. That means some 8, 9 or whatever. I mean whatever. So 10 is power minus 5. If you just look 10 is power minus 5, you can take the answer. I hope everybody is clear. I hope everybody is clear. Now, if you really want to calculate it, so you can definitely approximate it, because from 0.5, you have to do 2 steps of 0.1. So 1.3, that's approximately 2.6, approximately 2.5. So 3 plus 2.5 is approximately 5.5. Question is giving you 5, because these are all approximations. So that you can reach your answer ABCD. So I hope you know how to calculate NT-log now. You can do the same thing. This is the same question, so it will be a homework question for you. So practice NT-log here. Practice that NT-log here that I have told you. Moving to the logic. Now, again, a basic logic from ionic equilibrium. The question says, suppose at 60 degree Kelvin of water, at 60 degree Kelvin of water is this much. Okay. Ka, it should be beta Ka. K is, sir, dissociation constant of water. Okay, water is not an acid, so let's say Kw, because generally dissociation constant of water is represented as Kw. No. So Kw of water, sir, what is water? It is a universal solvent giving equal number of H plus ion and OH minus ion very negligibly, but giving equal number of H plus and OH minus ion negligibly at equilibrium. The value of equilibrium constant K is written as Kw because it is not at all moving forward. So value of K I write as Kw, and it is equal to H plus ion concentration into OH minus ion concentration at equilibrium. Now, if the value is given generally at 25 degrees Celsius, we know the value, it is 10 to the power minus 14. But I am increasing the temperature, so K will change. The question is telling you K is changing to 10 to the power minus 13. But sir, it is giving whatever, this is C minus C alpha, so it will giving C alpha times of this and C alpha times of this. That means both their concentrations are same. So let us take, because both are same, so both are equal, so let us square it. So value of H plus ion concentration will be 10 raised to the power minus 13 by minus 13 by 2. By 2 will be 6.5. So pH will be minus of log of this. So pH will be just 6.5. So calculate pH of water and also define, what is pH scale? pH scale is used to quantify that whether your solution is acidic, basic or neutral. So in this case, at pH 6.5, solution will be neutral. If pH is less than 6.5, solution will be acidic. If pH is more than 6.5, solution will be basic. If Kw is 10 to the power minus 13, that is at elevated temperature. I hope everybody is clear with this. Chal. Moving to the next question. Which says calculate the pH of solution. Now. Such dilution questions where you direct find application of normality. In my previous class, some of the students were saying, sir, normality questions. So normality questions are generally applied during the concept of equilibrium chapter only. Like for example, over here you are supposed to calculate pH. So in order to calculate pH, let us find the normality of solution. So first I am mixing base. This is base 1. This is acid 1 and this is base 2. So first let us calculate what is the concentration of H plus ions that I am furnishing in the solution. So concentration of H plus ion will be normality of acid. What is the normality? Because in order to know the concentration, you should always focus on what concentration term? Normality, because it deals with the valency factor in itself. So you do not have to write and bother about the reaction. So who is my acid? H2SO4. What is normality? Normality will be molarity into volume into valency factor. So molarity is given out to be 0.4. Volume is 200. Okay, it is in ml. So I am calculating this. You can even divide by, okay, let me make it by divide by 1000. So now our volume is in liters, into valency factor is 2. So this is nothing but 20 into 8. So this is 160. 1000 I'm not removing because I am focusing on this. This is 160 gram. This is 160 because here I'm calculating gram equivalent, because gram equivalent is normality into volume. So here this is this much of gram equivalent. Why? Because I do not have to bother about the moles taken. I hope I'm clear now. So this is 160 gram equivalent of acid I'm having. Now what is the concentration of OH minus ion from bases? Sir, it will be number of gram equivalent of this plus number of gram equivalent of the second base. So what will be number of gram equivalent of first base? Sir, molarity, which is 0.2, into volume, which is 300 upon 1000, into valency factor, which is for NaOH, it is 1. So this is first base plus what is gram equivalent of second base? Sir, molarity, which is 0.1, volume, which is 500, and valency factor of calcium hydroxide will be 2 upon 1000. I'm not bothered about 1000, but still for you I'm writing. So this is 60 and this is 100. So this is also 160. Sir, I am getting equal number of H plus and OH minus ion. If at all I was getting different, then whatever remaining you are having, that will give you either H plus ion or OH minus ion. So subtract them, and once you subtract them, you will get to know that what you are remained with, H plus or OH. So what are you remained with? Take minus log of that. Let's say if H plus was 170, so 170 minus 160 will be 10. So 10 upon 100 will be H plus ion concentration. Take minus of log of that value and you will be getting that pH. If OH was more, take minus log of OH, it will give you POH. In order to calculate pH, subtract with 14. In this case, because H plus and OH minus and both are equal, that means this is just neutral condition, and at neutral condition pH is simply 7. You do not have to move your pen. I hope everybody is clear with this. But yes, for such question you should know the concept of normality, how to calculate equivalent normality, which we have done in the yesterday's class. I hope everybody is clear. Chal. Moving to the next question, guys. The question says Ka of HCN is given. Sir, Ka of what is given? Ka of weak components are given. A as in this is a weak acid. So this is a weak acid. Then pH of this much molar HCN solution. So K is given and concentration is given, and you have to calculate the pH. So just this is a common sense, but I'm giving you with complete logic. But try to do this, try to put the formula directly in your examination. If you do not remember it, I'm making you revise it. So HCN being a weak acid will give very small amount of H plus and Cn minus ion. Equilibrium concentration can be written as C minus C alpha. So this will be C alpha, this will be C alpha. What is value of Ka? Sir, it is C alpha square upon 1 minus alpha. Now because it is weak acid, so this 1 minus alpha will approximately be equal to 1. So alpha will be equal to under root of K upon C. That means H plus ion concentration will be nothing but C times of alpha. Alpha is this, so it will be under root of Ka into C. Now this is the result. This is the result I want you to always remember for a weak acid, because if you remember this, then you can directly put it. So value of H plus ion concentration will be under root of Ka, already given, 4 into 10 raised to power minus 10. Concentration of acid already given, 2.5 into 10 raised to the power minus 1. 2.5 into 4 is 10. So this is 10 and 10 gone. So this is 10 raised to power minus 5. So pH will be minus of log of 10 raised to power minus 5. So this is simply 5. I hope everybody is clear. Good, 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 good. Moving to the next question, which says the pH of this much molar solution of HOCl. Now K of HOCl is also given. That means it is also a weak acid. So Ka given, concentration given, H plus ion concentration will be under root of Ka into C. I hope you can solve it. Once you solve it, you will be getting this. This is a homework for you. So same logic. Yeah. Moving to this question. Again, an NCRT fact, an NCRT logic. Why I'm making you learn it? Because yes, before NCRT is your for a NEET aspirant, it is a holy book. So giving those mathematical logics also from the book. Determine the ionization constant of acetic acid. If Kb for CH3 COO, okay. So this is my acid, but CH3 COO minus is the conjugate base. No, actually, beta, this question I've used. The team has given because I have to make you revise the conjugate acid base relationship, which is for a conjugate acid base pair, Ka and Kb of conjugate acid base pair is always equal to Kw. This is the result I want you to keep in your formula sheet and with yourself. So for acid, Ka is asked in the question, but Kb for the conjugate base is given, and it is given out to be 5 into 10 to the power minus 10, and it is equal to Kw, which is at 25 degrees Celsius will be 10 to the power minus 14. So dissociation constant of this weak acid will be nothing but 1 upon 5 into 10 raised to the power minus 4. So you can obviously change it. This will become 10, this will become 5. So this will be 2 into 10 raised to the power minus 5. I hope everybody is clear. Guys, done. Moving to the next one. Okay, we are done with equilibrium. This is the last. Acha, beta, I guess I'll be taking more questions from equilibrium. I will be taking more questions from equilibrium. The buffer solution and solubility or sparingly soluble salt, that is also left. But yes, because this is one, so we'll be departing. Okay, just let us attempt this question, and then we'll be departing for a 15 minutes break, and then we'll be meeting again. So the dissociation constant of acetic acid at a given temperature is this much. So dissociation constant as in Ka of acetic acid is given. The degree of dissociation of this much molar acetic acid in presence of, now this is an application of common ion effect. Like for example, if I have a weak acid like acetic acid, it will give very small amount of ions. But if I have used the common ion from a strong electrolyte, like here I have used a strong electrolyte HCl, HCl will completely ionize and will form H plus and Cl minus ion. So amount of H plus ion will be increased, and according to Lee-Chatelier's principle, its dissociation will be further suppressed. But whatever negligible value it is, question is asking you that value. So let's say that negligible degree of dissociation is alpha now. So this will dissociate C minus C alpha, and C alpha and C alpha is produced. But this is the very negligible value. So what is the negligible degree of dissociation now? It is C alpha. Sir, but because this is very negligible, so this C alpha, because H plus is given by this also and this also, and it is largely decided by this. So actually what will be the equilibrium concentration of H plus ion? Sir, it will be equal to the H plus ion given by strong acid, which is this 0.01. And let me write it in a different manner so that you can remember the picture. So this will be actually equal to, let's say this concentration is C. So this, not C, let's say C1. So this is C1. So this C1 is actually so huge in presence of this C alpha. So sir, if you add it, subtract it, it will not make any difference. So actually the H plus ion concentration will be nothing but, it will be only decided by the value of acid given by the strong electrolyte. Therefore, but yes, what never changes, sir, value of K, equilibrium constant for acid, will never change. So K will be equal to concentration of acetate ion into concentration of H plus ion, which is not at all depending upon this. It is actually dependent upon the strong electrolyte. So that is equal to C1, whose value is 10 to the power minus 2. upon concentration of acetate ion. Now it is not at all dissociating. So this C minus C alpha is already equal to C. This is my concentration C. So that is equal to 10 to the power minus 2 given. So this is gone. So what are we asked in the question? The dissociation constant is given, the degree of dissociation in presence. Okay, you are asked the value of alpha. So concentration of CH3COO minus will be C alpha. So C alpha, I know it is equal to K. So C alpha is equal to K, which is 1.69 into 10 raised to the power minus 5. So alpha will be equal to, what is the value of C? So 10 to the power minus 2. So it will be equal to 1.69 into 10 to the power minus 3. So 1.69. Okay. So option 3. Why? Just move the decimal, so it will be 1.69 into 10 to the power minus 3. It is playing with the options also. So I hope, yeah. So this was a very important topic of common ion effect, which is not I mean, most of the students are not comfortable with this, but yes, I have explained this, and I'm going to take 15 minutes break. So if at all you have joined right now, so you can go back and browse whatever we have done in this first half. We'll be meeting after 15 minutes. So this is 110. So 110, 120, 125 we'll be meeting. So we will be back at 1:25 p.m. I hope everybody just go have your lunch and we'll be meeting again. Okay? Bye bye. I mean, 1:25, I'm coming back. Don't eat much. Just eat 2 chapatis. Hello. Yes, guys. So, welcome back. I am live again. Let me just check that focus. Yeah, it's fine. Chalo, let's start beta. Now we have left. Hello, everybody. Hello again. Hello again. Hello again. Now, okay. So we are back. Now we have left few topics for ionic equilibrium. So let us finish those topics. Then we'll be quickly moving to sir in which class. Okay. Okay. So people are communicating. Beta, kindly do not socialize. Uh, rather invest your whatever time you're having in your concepts now. So let us finish the few topics of ionic equilibrium and then we'll be pushing towards chemical kinetics, class 12 physical chemistry, and last we'll be finishing with electrochemistry. So I guess we have a class at 3 p.m. of Shubhrat sir for physics, so we'll be finishing and we'll be finishing before 3 है ना. So we have, I guess we have 1.5 hours, 1 hour 30 minutes. Chalo, okay beta, moving forward. So the question says the next topic is definitely buffer solution. Buffer solution, JE also has asked, the NT has also asked during the mains examination a lot of buffer question, just the simple Henderson's equation. So what is a basic buffer? A basic buffer is when you have a salt of strong acid with a weak base along with that weak base. What is an acidic buffer? Sir, if we have a salt of weak acid with a strong base along with the presence of weak acid, so that mixture constitutes an acidic buffer and a basic buffer. Now after that, sir, sir, let us do a question to identify whether we can do it. Now I have a weak acid and I have a strong base. How many moles of base I have? 10 millimoles. How many moles of weak acid I have? 10 millimoles. So they will just neutralize, and because they will neutralize, so they I'm not, you must be remaining with the weaker counterpart in excess, then only you can create that buffer mixture. So this will not create a buffer. I have 10 millimoles of strong acid and I have 20 millimoles of this weak base. So they will create a salt and this weak base will also be remaining. So this will give you a basic buffer. So your answer will be option 2. I hope everybody is clear with this. Moving to the next one. Now we know how to identify whether we have a acidic buffer or a rather a basic buffer. Now the pH calculation, how to do it? Now this is just a neat question. The question says the pH of the solution containing 50 ml each of 0.1 molar sodium acetate. So this is a salt of weak acid, strong base, along with the presence of weak acid. So this is definitely what? This is my acidic buffer. How to calculate pH of an acidic buffer? Sir, it will create H plus ions. So pH of acidic buffer will be equal to pKa of the weaker counterpart plus log of what is the ion, what is the concentration of ions the salt are giving. So this will rather be concentration of salt upon concentration of weak acid. So pKa value is directly given, it is 4.75 plus log of what is the concentration of salt? Sir, 0.1 upon what is concentration of acetic acid? Sir, this is let's say this is 10 raised to power minus 1. So of the base is 10 raised to power minus 2. So I have log 10. So log 10 will be 1. So this value will be simply 5.57, as in option 2 will be your right answer. I hope everybody is done with this. Moving to the next problem from buffer solution. I hope everybody is good, guys. Chalo, perfect. Perfect. Now, a certain buffer solution contains equal concentration of X minus and HX. So that means I told you what is concentration of X minus, that is given by the salt. So the thing that we put na concentration of salt, actually that salt is the concentration of X minus that remains. So concentration of salt and concentration of weak acid both are given. That means log of salt upon acid will be 1, so log 1 will be 0. So log 1 will be 0. Kb for X minus is given. Sir, if Kb is given, but this is a acidic buffer, and an acidic buffer, because for an acidic buffer I need the value of Ka, but they are giving me value of the conjugate base. So what shall be the Ka value? Sir, you have already told us that Ka into Kb for a conjugate acid base pair is Kw. So value of K will be equal to 10 raised to power minus 14 upon Kb of the conjugate base, which is 10 raised to power minus 10. So it will be 10 raised to power minus 4. So pKa will be rather 4. So pH of this acidic buffer will be 4 plus 0. So your answer will be simply option 1. I hope everybody is clear with this. Moving to the next question, which says, perfect. I hope everybody is good. Chalo. Moving to the next question, which says, if 40 ml of 0.2 molar KOH is added to 160 ml 0.1 molar weak acid. So again, strong base and weak acid. What is the millimoles of this strong base? 8 millimoles. What is the millimoles of this weak acid? So 16. So ultimately, when acid and base will react, they will produce salt. So 8 will be gone. 16 minus 8 will be 8. So salt, which will be HCOO minus and K plus, will be how much? Sir, it will be 8 millimoles. Sir, weak acid that will remain will be what? It will again be 16 minus 8. That means 8 millimoles, although this is moles. In order to calculate concentration, you have to divide by volume. But ultimately, because we are taking logs of value of volume, which will be 40 plus 160, that is 200, will be cancelled. So why bother? So therefore, log of 8 upon 8 as in 1 will again be 0, because this is also an acidic buffer. So pH will be equal to directly pKa. I guess pKa we have... okay, pK is given, pKa, okay, K is given. So it will be equal to minus of log of Ka, which is 2 into 10 raised to the power minus 4 for the weak acid. Because log of salt upon weak acid is definitely log 1 is 0. So I'm not including that part. That part we have done. Oh, I'm sorry. That part we have done separately. So this is my pH. So pH will be equal to minus of log 2 minus plus log of 10. Why I'm saying plus? Because I am multiplying, because this will be minus of log 2 and minus of log of 10 raised to power minus 4. So minus plus, because I'm including 4 over here, because log 10 is definitely 1. So this is 4 minus 0.3 as in 3.7, but I guess in the question you are asked POH. So POH will be 14 minus 3.7 will be value of POH. So any value greater than 10 is definitely your answer. Perfect. I hope everybody is clear. Yeah. Good. Now we have got students responding. Perfect, guys. Moving to the next one. Now, the next question says, calculate pH of 10 to the power minus 2 molar KCN solution if dissociation constant of HCN is given. Sir, KCN, pH of 10 to the power minus KCN. Sir, now we have came to the concept of salt hydrolysis. Whenever you have a salt which interacts with water, it creates, let's say salt is Ba, so it produces BOH and HA as in corresponding base and acid. Obviously this reaction is salt hydrolysis. Opposite reaction is called neutralization. Now whenever this salt interacts, it depends upon the strength of acid and bases. Once we have, like for example here, this is a salt of KOH of a strong base. and HCN a weak acid. So hydrolysis of salt of strong base and weak acid, because as base is strong, so pH will definitely be more than 7. So instead of deriving the formula, I am giving you a trend to remember it. Because base is strong, so pH will be 7 plus. By what factor? Half of pK of the weaker part, which is acid in this case, plus log of concentration of salt. Sir, if it was strong acid, then it will be 7 minus. What minus? Half of pK of the weaker part plus log of concentration of salt. If both the components are weak, formula will be 7 plus half of pKa minus pKb. I hope everybody is clear with this. Okay, now put the value in this now. So pH will be 7 plus half of, what is pKa? Sir, minus of log of Ka. K is given to be 10 raised to power minus 10 plus log of concentration of salt is given out to be 10 raised to power minus 2. So yes, you are definitely going to land with such question in your NEET examination. So this will be 10 minus 2. So this is 8. 8 by 2 is 4. 7 plus 4 is 11. So your pH will be 11. I hope you are clear, guys. I hope you are clear. Good. Good. Chalo. Chalo. Moving to the next question, which says, what is the pH of 1 molar? Now this is a salt of strong base and a weak acid. Again, you are asked the pH, and Ka of acetic acid is given, so, and Kw is also given. So for strong base and weak acid, remember, let us revise the formula again. Because base is strong, so pH will be 7 plus. By what factor? Half of pKa, as in minus of log of Ka, which is 1.8 into 10 raised to power minus 5, plus log of C. C is the concentration of salt, which is given out to be 1. So log 1 is 0. So the only job you have over here is to calculate this value of log, which you definitely can. So practice it. And once you practice this, I guess I'm giving you answer also. You'll be landing somewhere around 9.4, obviously, because base is strong. Because base is strong, so pH will definitely be more than 7. I tell you one thing. Even such question comes in your NEET examination, now you do not have to do the calculation also. You know why? So base is strong. pH will be more than 7. What option you see more than 7? That's why for such questions you do not even have to calculate. But yes, for that you have to keep your eyes open. Chalo. That eyes during attempt of a question can only be opened once you are very much comfortable with your concepts. है ना? Chalo. Moving forward. The Kb of dimethylamine and K of acetic acid are given. So this is a value of pKb. This is value of pKa. That means both acid and base are weak. So again, formula of pH for mixture of salt of weak acid, weak bases, pKa minus pKb. Please make sure you are updating your formula sheet with such examples, and how to remember them. Iterate them more and more. So pH of salt of weak acid and weak base is 7 plus half of pKa minus pKb. I hope everybody is with me. Now into divide is your job, guys. Once you solve, you will get somewhere around 7.75. Moving to the next question, which says, what is the hydrolysis constant of, now this is OCl minus our hydrolysis constant. That means this must be a weak acid, the salt will be getting hydrolyzed of this. So ultimately we have to say the hydrolysis constant of this weak acid, this OCl minus, where the HOCl Ka is given. That means I have a weak acid. So if I have a weak acid, that means the base will be strong. So this is also talking about a salt of what? How does salt undergo hydrolysis? Let us revise that again. Sir, salt is always a strong electrolyte. So in ionic form, if I write, I always have to dissociate this. Water is not an electrolyte. So because base is strong, so it will definitely dissociate, and because acid is weak, it will not dissociate. So just check. Once you write the ionic form of equation, you will get you will get only the anion. So sometimes to such salt hydrolysis, the theory also say it's a anionic hydrolysis. So for this anionic hydrolysis, you are supposed to calculate the value of KH. KH is for any hydrolysis is equal to KW, that is dissociation is taking in universal solvent. So this is KW upon Ka as in dissociation constant of the weaker part. If both the components are weak, it will be denominator will be K into Kb. Else, whatever is the weaker component, the dissociation constant will come in the denominator. So here, acid is weak, so Ka will come in the denominator. So this is 10 to the power minus 14 upon Ka, which is given out to be 3 into 10 raised to the power minus 8. Now, so you can just solve it. Obviously, 1 by 3, so it will be something 33.33. So I guess it will be 10 raised to the power minus 7. Party minus 8. Yeah, perfect. So I hope you have got the answer, guys. Moving to solubility of, again a topic very important, of sparingly soluble salts. When a salt becomes sparingly soluble, when the concentration that the salt ionizes itself is even lesser than 10 raised to the power minus 2 molar. If it is between 10 raised to the power minus 1 and minus 2, it is sparingly soluble. And if it is more than 10 raised to the power minus 1, it is termed as a soluble salt. And this is molarity as in moles per liter. So I hope you are good with this. Now, sir, these sparingly soluble salts, they also ionize like a weak electrolyte. So for them, JEE, NEET, NTA loves their usage in your paper. Direct question comes, like for example, the very basic type of question is the KSP as in solubility product as in equilibrium constant of that salt which is not at all dissociating, like this is chromium hydroxide, its value of KSP is given. So that means, sir, you are saying chromium hydroxide is a sparingly soluble compound. Yes, so it will partially form chromium ion and hydroxide ion. If 1 mole of this is dissociating, 1 mole of this and 3 moles of this are produced, sir, it is also saying its solubility is very less. Let's say the small value is S. So 1 forms 1, so S will form S. 1 forms 3, so S will form 3S, where S will be the solubility of this guy. Value of equilibrium constant K will become KSP because this is not at all dissociating. So this denominator into value of K is written as KSP, which will equal to concentration of chromium ion into concentration of hydroxide ion raised to the power 3. This is S, this is 3S cube. So this is 3, 3 are 9, 3 are 27. S raised to the power 4. And the value is given out to be KSP is 1.6 into 10 raised to the power minus 3. So S will be equal to 1.6 into 10 to the power minus 3 upon 27. Oh, okay. It is, I guess this is 30 because every option is giving you 30 only. Raised to the power 1 by 4. So option 3. Good? Good, everybody? Chalo. Moving to, good, everybody? Yeah. Moving to the next question. Now, for example, for such a question, a precipitate of AgCl is formed when equal volume of the following are mixed and KSP is given. So, AgCl is a sparingly soluble salt. Why? Because its KSP is given. But if the solution is having the ionic product, as in the concentration of Ag plus and Cl minus ion, the concentration product has to reach this value. If it exceeds the value, then only precipitation will take place. Else, more and more ions can be introduced. Yes, the value is very small, but sometimes the question tricks you that when precipitation will start. So precipitation will only start when ionic product exceeds the value of solubility product. How to calculate ionic product? The ions that they are producing, concentration of those ions, the product should be calculated, which is called the ionic product. Like for example, this salt will give how much of Ag plus? 10 is power minus 4. This salt will give how much of Cl minus? So 10 raised to power minus 7. So what will be its ionic product? So 10 raised to power minus 11. Is 10 raised to power minus 11 more? No, sir, it is less. So no precipitation will take place. You can add more salt. Now, this is here Ag plus will be 10 to the power minus 5. Here it will be 10 to the power minus 7. Minus 5 and minus 7 is minus 12, sir. Here also it is very less. Minus is less. Now, Ag plus here will be 10 to the power minus 5. Here it will be 10 to the power minus 4. That means it is 10 to the power minus 9. Yeah, this value is greater than Ksp. So this will not be allowed, and here precipitation will take place. I hope everybody is clear. Moving to the next one. Next question says that at 25 degrees Celsius, the solubility product, again the solubility product Ksp of this is given. At what pH the Mg plus ion will start precipitating from us. Okay, now I am introducing a common ion. Now common ion effect is just the same which we have seen previously where in case of weak acid, sir, this is also a weak electrolyte. If I have magnesium hydroxide, then question is telling me it will sparingly form magnesium ion and hydroxide ion. If at all I am providing this magnesium ion by a strong electrolyte, so strong electrolyte will completely ionize and it will give you this much amount of magnesium, and this will decide the concentration of magnesium ion, and its solubility will further get suppressed. But let's say the new solubility is S, it will be very less value, but ultimately some will be dissociated. So let's say that value is S. So what will not change? The value of Ksp will not change. So value of Ksp is given out to be 10 to the power minus 11. So Ksp is equal to ions, sir, but concentration of magnesium ion will be decided by this. So this will be 10 to the power minus 3 into concentration of hydroxide ion raised to the power 3 upon, sir, this is not at all getting dissociated. So what was the concentration we have taken initially for magnesium? The solubility product is given at what pH will in form of from a solution of this much of magnesium ion. Okay, so we are not given. Okay, because I'm writing Ksp, so I just need to know concentration of ions. I even do not know the required, because this concentration will be constant, and that constant into constant is Ksp, so not required. So this denominator is not even required. Okay, so ultimately from here I will be having OH minus ion concentration. Minus 11 plus 3 will be minus 8 minus, yeah, this is minus 3 na, and this is minus 11, yes. So minus 11 plus 3 will be minus 8, and because this is, okay, this is 2 beta, this is 2, this is 2, so minus 8 upon 2 is minus 4. That means POH will be 4, but you are asked pH, so it will be 10, 14 minus 4. So answer will be 2. Yes, you have to be quick with your calculations, beta, because yes, calculation you can only perform with efficiency once you are comfortable with the logic. I hope everybody is clear. I hope everybody is clear. देखना message शायद okay, not required. चलो, perfect. चलो, moving to beta, side. Beta, I always keep on giving side so that you may at least read the questions properly. But yes, because you have a class at 3, so I'm trying to wrap the whole of the physical part. I mean, I've just increased my speed because obviously you have your physics class also at 3 p.m. Now, Ksp of AgCl at 25 degrees Celsius is given out to be this much. So this is the value of Ksp. Find the solubility of AgCl, but this solubility you do not, molarity is moles per liter, but here you are supposed to calculate weight per liter. So let us first calculate molarity in an aqueous solution containing, okay, now again this is a strong electrolyte, so this is a strong electrolyte, so it will create more of Ag plus ion, and for this Ag plus ion will be decided by the strong electrolyte. So again you have to do this Ksp, which is given out to be 1.5 into 10 raised to the power minus 10. It will be concentration of silver ions at equilibrium into concentration of Cl minus ion, and that Cl minus ion will give you the solubility also. But Ag plus ion concentration will not be decided by this sparingly soluble salt. It will be decided by strong electrolyte, which is 10 raised to the power minus 2. So S will be equal to 1.5 into 10 raised to the power minus 8. But this is moles, this much mole per liter. In the question you are asked weight. So with moles, how to calculate weight? Multiply by molar mass. Molar mass of AgCl will be 108 plus 35.5. So the solubility will be 1.5 into 10 raised to the power minus 8 into 143.5, and unit will be gram per liter. I hope now obviously you can do the into divide, but yes, do this calculation once you are practicing these questions. Moving to the next one. Now, okay, so from here we are starting chemical. Now Ionic also, it's done beta. Now quickly moving to chemical kinetics. We are not practicing so many questions around chemical kinetics, but yes, the major type of questions, the major type of concepts, I'm discussing those concepts. So for chemical kinetics, I'm starting. The first type of question that you are asked in your examination is, let's say I have a reaction, A moles of A reacts with B moles of B, produces C moles of C and D moles of D. So first type of question that is asked out of you is to know the differential form of rate law. So differential form of rate law says that rate of a reaction is equal to rate of disappearance of reactant, that is minus d by dt of change in concentration of A with respect to time upon stoichiometric coefficients. So what is this? Is rate of disappearance of A upon stoichiometric coefficient. So rate is equated with rate of disappearance of A using the stoichiometry in the denominator. Rate will also be equal to rate of disappearance of another reactant B upon stoichiometric coefficient of B. Rate will also be equal to rate of appearance of C upon stoichiometric coefficient of C. It will also be equal to rate of appearance or production of product D upon stoichiometric coefficient of D. In the question, let's say rate of appearance of D is given and you are asked about the rate. So you just have to put the value over here, multiply the coefficient, and you will be getting your rate. I hope you are clear. Now, this is the first type of question we get in chemical kinetics. Moving to next type. The second type of question you get in chemical kinetics is regarding order and molecularity of a reaction. So what is order of a reaction? I'm just giving you with one basic example. Like for example, I have an alkyl fluoride. Now alkyl fluoride, whenever is subjected to any base, how does elimination of this alkyl fluoride take place? How does this elimination of alkyl fluoride take place? First of all, the base comes and gives away the electron. First of all, the base comes and give away the electron to hydrogen, and electron of hydrogen stays with carbon and a carb anion is formed. So let us form that carbon ion. This is my carbon ion. Because C bond F is so small that it is very difficult to break it. So I am explaining the mechanism of E1CB to give you a feeling how to identify and differentiate between order and molecularity of a reaction. Now, once this base is formed, the first step, if you go to chemical kinetics, as in if you try to judge the speed of a reaction, you will find this step is very fast, which is the first step. Now with second step, what happens is the carb anion that you have formed will force the extra electron, and slowly and gradually fluorine will move, because C bond F is very small, bond length small, so bond is very strong, it is not dissociated easily, and therefore this reaction is quite slow, very reversible, not at all moving forward, but yes, with passage of time it happens and alkene is produced. So what step decides the rate of reaction? Slowest step. So this becomes my rate determining step. And who decides the rate of reaction? This. In this rate determining step, how many reactant molecules are there? One. So because I have only one reactant molecule, therefore theoretically speaking, molecularity is the number of reacting species in each step. Molecularity is defined for each step, but in general, for a reaction which is having more than one step, generally it is not written anywhere, but yes, it is generalized that molecularity is defined for the slowest step. So for this slowest step, molecularity is what? 1. What is molecularity? Number of reactant species. So how many reactant species I'm having? 1. So molecularity is 1. But what is order of reaction? Sir, order is decided by the slowest step, and order says that rate of a reaction is directly proportional to concentration of reactants raised to the power stoichiometry. Now, if you calculate rate of reaction, so rate of reaction will be decided by second step will be carb anion, because carb anion is my reactant raised to the power 1. But do I have purchased this carb anion from market? No, sir, because I cannot increase the concentration of carbon, and that is not in my hand. What is actually reactant for you? Sir, alkyl fluoride and base. So if I write equilibrium constant for this, so equilibrium constant will be concentration of product upon concentration of reactant. So what will be the concentration of product? Sir, it will be equal to concentration of this and this, because I'm saying proportionality to, so instead of carbon ion, I'll say rate is proportional to concentration of alkyl fluoride raised to the power 1 and conjugate and any base raised to the power 1. This base is generally a conjugate base, hence the name E1CB. Now, after this, raised to the power 1, raised to the power 1. So what is order? Whenever you have a experimental value of your rate of reaction in this form, where rate is dependent on the concentration of the reactant species, then summation of power of reactant terms give you order. So order of reaction will become 1 plus 1 as in 2. Order and molecularity are different, where order is a experimental concept while molecularity is a theoretical concept. I hope everybody is with me till this point of time. Now, after this, what I'm telling you, sir, how to determine theoretical questions you can get out of order and molecularity. Apart from that, you get a table where concentration of reactants are given, and you do not know what is the order with respect to whom. So you just say, you just do this. What you do? You just, now the third type of problem is the calculation. So calculation, how you do? In that table of concentration term, you just see how the concentration of reactants A and B are changing, and rate is proportional to concentration of A raised to the power X, concentration of B raised to the power Y. For example, it is 0.1, 0.1. This is concentration. If I am, and a rate is also given. So let's say rate is R. If I'm keeping A as 0.1, but I'm doubling B, and rate is also becoming doubled. That means keeping concentration of A constant, if B is doubled, that means B is multiplied by 2. So 2 raised to the power Y is equal to, rate is also doubled. So 2 raised to the power 1. That means in this case, Y will be 1. Suppose if you are changing, if you are keeping this as 0.1 only, and this I'm doubling, but rate is still remaining the same. That means even if I'm doubling it, rate is not getting changed. That means with respect to A, order is 0. So such type of questions is filled in your NT examination. The third type of problem from chemical kinetics. Next type of problem from chemical kinetics, the fourth type, is the rate law. What rate law? It's a differential rate law. Now this is the most famous thing. Zero order and first order kinetics. I'm directly giving you the formula. For zero order reactions, the rate law is concentration of reactant remaining at time t is equal to minus kT plus concentration of reactant at time 0. If you calculate T half for such a reaction, it will be equal to initial concentration A naught upon 2K. For a first order reaction, the rate law says that concentration, I mean, that's a exponential factor. So the relation is KT is equal to ln of concentration of A remaining at time t upon concentration of A that you have taken initially. If you just try to calculate T half, so at T half, concentration of A remaining will be A naught by 2. So, okay, I'm sorry, it is A naught. I'm sorry. It is A naught upon AT. So, at half of the reaction, it will be A naught by 2, so 2 will come in the numerator. So T half for a first order reaction will be ln of 2 upon K, which you can obviously see it is independent of the initial concentration. So every nuclear decay, these all decay are zero order kinetics, therefore they do not depend upon the, they are first order kinetics, and therefore they do not depend upon the initial concentration taken. Now, one more thing, you should always remember that T half, as per this conclusion also you can say, T half is proportional to initial concentration raised to the power 1 minus n, because for a zero order reaction it is n minus 1. I'm sorry. It is n minus 1. For a zero order reaction, it will come in the numerator. For a first order reaction, it will be not dependent. For a second order reaction, it will be inversely proportional to A naught. So this is also a very famous result which will help you to identify what is the order of the reaction. The n value can easily be determined if you know the relationship with the T half. I hope everybody is clear, guys. Now, last topic for chemical kinetics that everybody should remember is the fifth, I guess is the fifth point, na? Is the collision and Arrhenius theory. Is the collision theory or Arrhenius theory, which says every reactant, whenever you have a chemical reaction, let's say this is the enthalpy of reactant and let's say this is the enthalpy of product. For such a reaction, you can obviously see here delta H is positive. It can either be negative also, for exothermic also, for endothermic also. Whenever reactants are converted to product, they always attain a maxima with respect to energy. So here I'm plotting energy and this is progress of reaction. So reaction always attains a maxima of energy, and the magnitude by which the energy is increased, it is termed as activation energy. And who is capable of climbing this activation energy barrier? Only strong intermediates. Therefore, through organic chemistry, this is the help of chemical kinetics which is provided to organic chemistry, that all the reactant do not form product. Only those reactants who has a capability to form a activated intermediate. And for an intermediate, which intermediate can be formed? Which is more stable. So for an intermediate, the intermediate which is more stable is able to climb this activation energy barrier as well. So for an intermediate, if it is more stable, it is having high energy also. For end products, we say if energy is high, stability is less, not for intermediate. I hope you're clear. Now, what is the mathematical thing? Apart from this, what is the mathematical thing that you should know? That the rate of reaction is equal to Arrhenius constant or pre-exponential factor A into e raised to the power minus of this activation energy upon RT. At two different temperatures, K1 by K2, obviously you can do the log thing also. So ln of K will be equal to ln of A minus EA upon RT. So at two different temperatures, you can do that, and ln of K2 by K1, EA will be cancelled. So thereby, with that conclusion, you can calculate activation energy. These are the topics which are highly asked in chemical kinetics, and we are done with for chemical kinetics. Now moving directly to electrochemistry. Last topic. Now moving directly to electrochemistry. And I want everybody to bring out your pen and copy and start attempting with me. So I hope we have participants who are attempting questions with me. Chalo. So with that, let us try and finish electrochemistry. Now, first type of question which we get for electrochemistry is identification of the electrochemical cell. Now, in the galvanic cell, this is the cell, how the cell is represented. In the left side, we represent the anode, and in the right side, we represent the cathode. Cathode is the electrode at which reduction take place. Anode is the electrode at which oxidation take place. The electron, sir, because it is getting oxidized, oxidation, anode is oxidation, so it is loss of electrons. So obviously the question is asking you, electron will flow from, sir, it will flow from copper to silver, because anode is the electrode at which oxidation takes place. So a very easy question, but yes, a conceptual one. Now, next is, the question is, when applied external potential, opposite potential in case of Daniell cell is less than 1.1 volt. Now, what is a Daniell cell? Sir, the zinc copper couple acts as a Daniell cell, where zinc acts as anode. We have already seen it in the previous slide, and copper acts as cathode. Now, if we just try to calculate the value of E naught cell, it will be equal to E naught cathode. Who is cathode? Copper, but E naught is the reduction potential, minus E naught anode. Who is anode? Zinc, but E naught is reduction potential, so Zn plus 2 forming Zn. If we put these values, the E naught cell for this zinc copper couple is 1.1 volt. So if I'm using an external potential whose potential is less than 1.1 volt, then the electrochemical cell will have no impact. The direction of flow will remain the same. But yes, if it is exceeding 1.1 volt, then it will become that electrochemical cell will be becoming an electrolytic cell, and hence everything will be changed. But here, everything will remain the same, as in electron will keep on flowing from zinc to copper. I hope everybody is clear. Yeah. Now, whenever we have that electrochemical cell, generally a salt bridge is introduced. You must have seen that salt bridge. The purpose of the salt bridge is to maintain electrical neutrality, and the ionic conductance is maintained. Why? Because in the anode, zinc ions will be increasing. In the cathode, the negative ion will be increasing, because copper is reducing at cathode. So the opposite ion are placed in the salt bridge, in where the salt bridge is solidified, so that the liquid solution may not fall down due to gravity. So it is solidified using agar agar. It is boiled with agar agar. But what electrolyte is boiled? That electrolyte is boiled whose cation and anion have equal transport number. What is transport number? Their ability to move. So what is the famous electrolyte which we use as a electrolyte for that salt bridge? Potassium nitrate. Why do we use it? Because the transport number of cations and anions are equal. So what is transport number? Their ability to move. So what is ability to move as per physics, sir? Their velocity. So velocity of them are same, therefore there is no production of liquid junction potential. I hope everybody is clear with this. Moving to the next question, which says, such questions also are very famous, beta. Very famous. Now, what does this question tell you? Standard reduction electrode potential of 3 metals are given. Now, this is reduction potential, and you are asked the reducing power. So, what is reducing power? I should be a strong reducing agent. So, reducing agent reduces others. So, if I reduce others, I will oxidize myself. So who will oxidize itself? Who will have maximum oxidation potential, or rather least reduction potential? So among them, who has least reduction potential? This, or this? So this is the least reduction potential. Who is having this least reduction potential? Z. So Z having least reduction potential. So it will behave as a strongest reducing agent. Only one option is telling you that. Obviously, you can judge that answer moving to the, I hope everybody is clear with this. Moving to the next one. The next question says the standard reduction potential of the half cell are given. Now again the same thing you have to do. Who is the strongest oxidizing agent? Oxidizing agent oxidizes others, therefore reduces itself, so it should have strongest reduction potential. So who has strongest reduction potential? Sir, highest value, all the value are reduction as in gain of electron. So who has highest value? This is highest, so F2 is the strongest oxidizing agent. And who has the lowest value? So this has the lowest value. That means I minus will be the strongest reducing agent because it will reduce others and oxidize itself, as in it will give electron. I hope everybody is clear now. I hope everybody is clear. Okay, perfect. Now moving to the next question directly from Nernst equation. What does Nernst equation tell you? Nernst equation tells us that we, like for example, we are given a reaction and we are supposed to calculate its E cell. So how to calculate E cell, sir? Beta, according to Nernst equation, E cell is equal to E naught cell minus RT upon NF into ln of equilibrium constant of the reaction, because if reaction will reach equilibrium, then it will not give any potential. So E cell is equal to E naught cell. Generally the reaction is done at standard conditions, as in temperature is fixed, and in that standard condition this value becomes equal to 0.059. So we just remember this data upon number of F is Faraday number, which is charge on 1 mole of electron. So 1 mole of electron into electronic charge, that is 1.6 into 10 to the power minus 19. It comes out to be 96500. Putting all that constants value, the we get 0.059, because ln is also converted to log with a multiplier of 2.303. So all those constants we remember. Now what is the number of electron transferred? Sir, 0 to plus 2, that means electron transferred is 2, into log of concentration of product, but concentration of only ions, because pure solid and pure liquid do not impact the state of equilibrium. So concentration of magnesium is Mg plus 2 raised to the power 1. So it will be 13 into 10 raised to the power minus 2 raised to the power 1 upon concentration of Ag plus ion squared, as in 1, 2, 3, 4, as in 10 raised to the power minus 4 raised to the power 2. So yes, what is value of E naught cell given? E naught cell given to us is 3.17. Yes, you definitely have to solve this, because I guess this is also a question from NCERT. Why I have taken this question? Because I want you to give you the logic, because ultimately in your NEET examination you are going to get a question from on Nernst equation, and what you have to do in that question? Calculation. So for practicing, calculate, practice an NCERT question. It is giving you logic also, and obviously the feeling also that. But yes, do the calculations better back at home. Okay, chalo. Moving to let us practice this question as well. So this question says, for a reaction A reacting with B, for this reaction Kc is found to be this much. Now you have to calculate standard EMF. Sir, how to calculate standard EMF? Now for electrochemistry combined with thermodynamics, through thermodynamics we know delta G is equal to delta G naught plus RT ln of Q. We know this through thermodynamics. I'm telling you here also. At equilibrium, delta G becomes 0 and Q becomes equal to K. Therefore, delta G naught becomes equal to minus RT ln of K. Very important conclusion. And also, delta G naught in terms of cell potential is equal to minus NF E naught cell. So if you know these conclusions, it will be directly helping you with mathematical questions. But yes, you have to practice questions. It will be there in your NEET examination. I'm giving you the complete conceptual revision. Hai na? So for example, for this question Kc is given and you are supposed to calculate E naught cell. So actually for this question, what is given? Sir, K is given and you are supposed to calculate E naught cell. So let us compare it, or else you can directly do this using Nernst equation. So what is Nernst equation, sir? E cell at equilibrium, E cell will be 0. So E naught cell will be equal to 0.059 upon n into log of q will become k, because Nernst equation at equilibrium E cell will also become 0. So E naught cell will be equal to RT upon NF into ln of k, putting the value. That's why this 0.059 is helpful. So ultimately we are supposed to calculate E naught cell. So it will be equal to 0.059, can also be written as 0.06. What is the number of electron transferred? So from 0 to plus 2. So n is again 2 into log of k. What is k? 10 is to power 12. So easy peasy calculation that we have to do. I hope few of you have got the answer. I guess once you solve, you will get 0.34. Any student who is solving? Chalo. I guess everybody's listening to the concepts. No one is solving, so no worries. Chalo. Next question. Again, acha, no, Shiny is solving. Perfect, beta. This I always used to say. Even I have one active student working, more than sufficient for me. Chalo. Moving to the next question. The standard electrode potential of zinc is given. What will be the standard potential of 2 molar? Now, the standard potential is given. Sir, 2 molar? Actually, whatever potential is, sir, potential is work done to move a charge. Sir, work done is extensive, charge is extensive. So extensive upon extensive becomes intensive. And because this is intensive, so you multiply your concentration by double it, triple it, whatever you do, it will not impact the potential. So potential will remain the same. It was just a question to trick you. I hope everybody is clear. Now, if we know this, now one very important conclusion again. The conclusion is, the oxidation potential of hydrogen electrode. The oxidation potential of hydrogen electrode at pH this is. So let us derive a basic calculation. So it is asking about oxidation potential. So how to write the reaction? Oxidation means oxidation state should increase. So from 0 to plus 1. So hydrogen gas from 0 going to H plus. This is oxidation. Oxidation state is increasing. Balance the reaction. This is 2 and 2 electrons. So for this reaction, if I write Nernst equation, so it will be E oxidation potential will be equal to standard oxidation potential. Sir, for hydrogen, we know it is 0, but still I'm writing. For electrode, I'm writing Nernst equation. So electrode potential is equal to standard electrode potential. This is not electrode potential, this is oxidation potential. So Nernst equation holds the same. So oxidation potential is equal to standard oxidation potential minus 0.059 upon number of electron transferred is 2 into log of concentration of product, which is H plus ion concentration squared, upon partial pressure of hydrogen is generally 1 bar. It is also given 1 bar 1 atm, so it is not taken. Now this 2 and this 2 will be cancelled because log A raised to power B minus of log of H plus will be pH. So I am giving you a formula that you should remember, that oxidation potential, this is oxidation potential, it is equal to minus is given over there. So this is 0.059 into pH. A very important result. If you learn this result for your examination, I am telling you, you are going to get one question from this. I hope everybody is clear. You can directly put this in the formula, and I guess once you put, you will be calculating pH, because this is just mathematics now. Done. Moving to, so moving to the questions from concentration cells. The thing that we read in physics, V is equal to IR, Ohm's law. Here also we have some conductivity cell. Now these conductivity cell, what we do, we take solution. What solutions are? Obviously electrolytic solution will conduct. So these electrolytic solutions, when how the ions are conducting. So I am talking of electrolytic conductance. In your physics, you talk of metallic conductance. Now, the solution is always kept in a vessel. That vessel is a cell. The cell has some length and the cell has some cross-sectional area. So ratio of L upon A is called cell constant, and to this cell constant we refer as G stick. I hope everybody is clear. Now, resistance of this cell is equal to rho L upon A. Instead of resistivity in chemistry, we are focused on conductivity or specific conductance, which is 1 upon rho. So 1 upon rho is termed as K. So if this is written as 1 upon K, then K becomes equal to 1 upon R into L by A. L by A I'm writing as G stick. What is 1 upon R? Sir, 1 upon resistance is conductance, and conductance we write as G. So a very important formula, that K is equal to G into G stick. Now, sir, what is molar conductivity? If this is conductivity as in conductance of a solution that is present in 1 cubic centimeter of a electrolytic solution. What is its molar conductivity? Molar conductivity is defined as K into 1000 upon molarity. This molarity is the concentration of the electrolyte that I'm using. Now, some people are answering also, so I'm first giving you all the logics. Now coming to the question. So specific conductance of this much molar, so this is molarity, is this. Oh, this is Siemens per centimeter, so this is value of K. You have to calculate molar conductance as in lambda m. So lambda m will be equal to this K given into 1000. Why? Because why I'm using this 1000? Because in this case lambda m will be coming in Siemens centimeter square per mole. Now, sir, if it is in meter, then this 1000 will go in the denominator. You have to remember this formula. It will be very much used, and obviously most of the students are answering also. Now they have started answering, so it will be 7:30. I hope everybody is clear. Now, this is a basic question from NCERT, so whatever I have given you will be a homework for you. This is all about, now coming to Kohlrausch law. Kohlrausch law and its application. After discussing those conductivity, specific conductivity and molar conductivity, let us move to questions regarding Kohlrausch law. Now, Kohlrausch law tells us that the limiting molar conductivity, because if you plot that conductivity, that molar conductivity for strong and weak electrolyte, you get curves like this. For a strong electrolyte, limiting molar conductivity decreases, lambda m decreases, but it decreases linearly with under root of concentration. The graph is the equation is lambda m is equal to lambda m naught minus constant times of under root of C. This is for strong electrolytes. For strong electrolytes. For weak electrolytes, it is rather a rectangular hyperbola. For weak electrolytes, it is rather a rectangular hyperbola. If I try to extrapolate this, then for strong electrolytes, we can always find the limiting molar conductivity. That is conductivity when concentration is 0. That means dilution is infinite. But for weak electrolyte, we cannot find it. So we use Kohlrausch law, which says that limiting molar conductivity of any electrolyte, whether strong or weak, is equal to summation of ionic, is limiting molar conductivity of its constituent ions. Point number 1. Point number 2, which Kohlrausch law gives, is that degree of dissociation. If at all you are having a weak electrolyte, so degree of dissociation of that weak electrolyte, you can calculate how? Its molar conductivity at any given concentration upon its molar conductivity when the concentration is 0. So when concentration is 0, but volume is infinite. So people write it as lambda m naught also and lambda m infinity also. I hope everybody is clear. Now putting that into this question, which says the molar conductivity of this much molar. So this is the molarity of methanoic acid is this much. So this is the value of lambda m. You have to calculate its degree of dissociation, that is alpha. Sir, you have already told us how to calculate alpha. But in order to calculate alpha, this is the value, this is the concentration, that is molar conductivity. In order to calculate alpha, I need to know lambda m, I need to know lambda m naught, but lambda, it is a weak electrolyte. See, for methanoic acid, what will be ion? Sir, methanoic acid is HCOOH. So it will be forming H plus ions and HCOO minus ions. So limiting molar conductivity will be 349.6 plus 54.6. This will give me value of lambda m naught. So value of alpha will be 46.1 upon whatever this is. If you solve, you will get your answer. Multiplied by 100, you will get your percentage. I hope everybody is clear. I am able to score more 100 studying through PYQs. Yes, beta, you are definitely able to. PYQ is the only holy grail to crack your competitive paper, beta. Don't worry, but yes, you have to do it, not ask it. Do it also parallelly. Moving forward. So I hope everybody is. Let me see how many questions I have. Okay, we are just. Now, let us do some questions. Let us do this. We are just ending, है ना? Let us do and attempt this question now. Now, the conductivity of a saturated solution of BaSO4 is given. Now, this is conductivity as in value of K is given out to be this much. What is its unit? In centimeter only. Remember, have a look at the units also in electrochemistry. And its molar conductance is this much. So this is value of lambda m in centimeters only. Now you are supposed to calculate the value of KSP. Hey, sir, KSP? What is KSP? Beta, what is BSO4, sir? We know because KSP is given. That means although this is a salt, but this is a weak electrolyte. So what is the ions that it be furnishing, sir? Negligible. But still, even a sparingly soluble salt has a small amount of solubility. Let's say that solubility is S. So that S solubility will be your molarity, because that will be the concentration of ions that you will be getting in your solution. Therefore, you already know lambda m is equal to K into 1000 into molarity, but that normality for a sparingly soluble salt, which is barium sulfate, which will rather dissociate and form very small amount of Ba+2 and sulfate ion. Agreed. But ultimately, what is its solubility? What is its percentage? Sir, it is S. That small value. Remember from ionic equilibrium. So that S. Value of lambda m is given. Value of K is given. Multiply this 1000. You will get your value of S. But S is not asked in the question. They are asking you value of KSP. And KSP for a sparingly soluble salt will be equal to, for this type of salt, it will be equal to S square. So your answer will be S square. Yeah, perfect. Somebody is solving also. Perfect, beta. Perfect. I'm very happy that even with my ending of the slides presentation, students are solving. Sonam, acha nahi, so not Sonam, Henry answered it. Perfect, Henry. Chalo. So I hope we have, yes, I have taken lesser number of questions over here because we have time constraint, but I'm dealing with all the logics. Now, coming to Faraday law. So quantitative analysis and qualitative analysis. Quantitative analysis is mathematics. Qualitative analysis is again theory. So that theory, obviously, if you have read, you can revise it. But yes, quantitative analysis I'm doing. It is just two law. Faraday first law says that weight deposited is equal to ZIT, where Z is electrochemical equivalent of the cell, which is nothing but E by F into IT. What is E? E is equivalent weight. I've discussed yesterday. That is molecular weight upon valency factor into Faraday's number into I, which is current in ampere, and T, which is time in seconds. Now, but sometimes you just have to be very quick with your common sense, which says, like for example, this question: number of Faraday required to liberate 8 gram hydrogen gas. Now, I want hydrogen gas to be liberated. So hydrogen gas can be prepared how? Sir, it can be prepared when H plus takes electron, hydrogen gas is produced. So if I produce 1 mole of hydrogen gas, I'll be requiring 2 electrons and 2 of H plus. So in order to produce 1 mole of hydrogen gas, how many electrons are required? 2. So 1 mole will require 2 mole electron. 2 mole electron will have what charge? 1 mole has 1 Faraday, so 2 mole has 2 Faraday. So 2 Faraday charge will be required when 1 mole hydrogen gas will be produced. 1 mole hydrogen gas as in 2 gram hydrogen gas. So for 2 gram hydrogen gas, I need 2 Faraday. So for 1 gram, I need 1 Faraday. So for 8 gram, I need 8 Faraday. So yes, sometimes, yeah, perfect. Now we are overflown with people solving questions. Perfect, guys. Moving to the next one. 0.5 ampere current is passed through an acidified silver nitrate solution for 10 minutes. And you have to say the mass deposited. Again, the same thing. W is equal to ZIT. Z is E by F. E is molar mass upon valency factor into F. So this is E, I, T. Let us put the value because such questions are very famous. Molar mass of silver nitrate. Silver nitrate we will not be 1.8 beta. Silver is 108. Silver nitrate is AgNO3, na? Silver is 108, nitrogen is 14, and this is 48. It is given 108. So I'm not putting this mass because I guess this is a printing error. So let me, acha, nahi, not printing error beta, because here we are calculating for silver only, no? Because ultimately silver from silver nitrate, silver would be taking one electron and will be deposited. So ultimately who is deposited? Silver. I'm sorry, silver, because we are doing this for silver. So atomic mass of silver is 108. Valency factor of silver is 1. Faraday number is 96500. Current is 0.5. And then time, how much time I'm taking to pass this? 10 minutes, but it should be in seconds. SI unit of time is seconds, so into 1 minute into 60 seconds. Yes, you just have to do the into divide now. Into divide, if you do, you will be getting this as your answer. We are just ending about two more questions. Yeah, perfect, Henry. Perfect, Henry. Chalo, moving forward. Now, if you have two different electrolytic solutions, but you are passing same amount of charge as in current, that is, they are connected in series. So this is Faraday's second law of electrolysis. If charge passed is same, then weight of first electrolyte liberated at any electrode upon weight of second electrolyte liberated at any electrode on the other cell is equal to equivalent weight of that liberated or deposited component. So equivalent weight of 1 upon equivalent weight of 2. Let us see what are the two things. One is aluminium and another metal is sodium. Aluminium deposited is 1.8 gram. Sodium deposited we have to calculate. Equivalent weight of aluminium will be atomic mass upon valency factor, which is 3 for aluminium because aluminium is plus 3. And for sodium it is atomic mass of sodium upon valency factor 1. So if you just solve this also, I guess you will be landing up with 4.6. Perfect. Henry is solving like anything. Henry is solving like anything. Perfect. Okay, so boss is also here. I mean proxy. Chalo, moving forward. Last question. You have to compare list 1 with list 2. Again, question from Faraday law of electrolysis. 1 mole of H2O2 producing oxygen. So oxygen from -2 is going to 0. Just remember, yesterday we have done oxidation number method. So -2 to 0, what is number of electron charge transfer? 2. So one mole will have 1 mole of O. 1 oxygen, it is from -2 to 0. How many electron transfer? 2. So 1 mole will have 2 Faraday of electron transfer. So do I have 2 Faraday? Yes. So A is 2. A is 2. Okay, so I am left with two options now. Manganese here is in +7 state, here is in +2 state. So obviously charge transfer will be 5. So 5 Faraday as in 4. So B is 4. B is 4. B is 4. We have got our answer. Obviously, you can do that for others also. Just one more logic I'm giving you at the end because I do not have that question, but yes, it is really very important logic, highly asked by NTA. Potential is not additive, remember, but delta G is. Like for example, they are also giving, and these questions are also very famous. Like for example, I have E naught value for let's say for Fe plus 3 taking 3 electrons and forming Fe plus 2, E naught is x volt, is the value of E naught. Similarly, for Fe plus 2 taking 2 electrons and forming Fe, let's say the potential is Y volt, and you are asked that Fe plus 3 taking 1 electron and forming Fe plus 2, what will be the value of E naught for this? If this is your question, because such questions are very famous, beta. X volt, Y volt. Sir, you have told E naught is intensive, so I can't add and subtract. Whatever you do with reactions, you can't do with E naught. But what is additive? Delta G. So let's say for this reaction, delta G is delta G1, and for this reaction, it is delta G2, and for this reaction, it is delta G3. So definitely we know that delta G3 will be equal to, how to get these, if you add first reaction and subtract it with second reaction. So 1 minus 2, Fe plus 2 will come over here. So delta G1 minus delta G2. I hope you are getting it. And we have equated, yes beta, this is more than, like you have to revise it completely, wiki, then it will be more than sufficient. What is delta G in terms of, it is delta G naught. What is delta G naught in terms of E naught cell? Minus E naught cell. So minus NF E naught cell. What is N? Number of electron transfers. So for third, it is 1 electron transfer. So minus 1 into F into E naught. This E naught we have to identify. What is delta G1? Minus, what is electron transfer? 3. F and E naught cell is given out to be X volt. This is delta G1 minus. For delta G2, it will be minus, electron transferred is 2. So 2F and E naught cell of this is given out to be Y. I hope everybody is very clear with this now. F gone, minus gone. So your E naught is nothing but 3x minus 2y. I hope everybody is clear. Sir, class ended? Chalo. So now I am ending it with this. I wish everybody a very best of luck. We'll be meeting soon with other package for chemistry, where I'll be trying to make you revise your organic and inorganic concepts as well. But yes, this is it from my side, from the physical chemistry side. You have your, so whether these are beta, these are Monish, these are exact NEET level questions, beta, not JEE level questions. Why I will overburden you with JEE level questions? So these are all relevant questions, beta, relevant topics, beta. But yes, you have to be very, very vigilant with the revision. So I hope you will do it. You are doing it. And best of luck. I'll see you soon.